If you like the space and learn about its curiosities, consider subscribing to the channel. Thank you for your attention and enjoy the video. Planet Earth has been the cradle of humanity for millennia, a seemingly familiar world orbiting a relatively average star in an unremarkable part of the Milky Way. Yet, beneath its familiar atmosphere, the planet harbors mysteries that have puzzled scientists and explorers for generations. What we often overlook is that Earth itself is as much a part of the cosmic story as the distant stars and planets. To truly understand the cosmos, we must first unlock the secrets of our own planet. These secrets not only give us insight into Earth's past and future, but also into the forces shaping the universe. One of the great enigmas of Earth lies deep within its core, where temperatures soar higher than the surface of the sun. The core is a cauldron of molten iron and nickel, churning and swirling in patterns that generate Earth's magnetic field. This invisible shield protects us from harmful cosmic radiation, allowing life to flourish on the surface. Yet, the magnetic field has been known to weaken, shift, and even reverse. Scientists are still trying to understand the full implications of these changes and what drives such monumental shifts in the heart of the planet. Could it be the harbinger of a magnetic pole reversal? Such events have occurred in Earth's distant past, but we don't yet know what impact a future reversal could have on modern civilization. Beneath the continents and oceans, Earth's tectonic plates float on a layer of semi-fluid rock known as the mantle. These plates are in constant motion, driven by forces deep within the Earth, and this movement is responsible for earthquakes, volcanic eruptions, and the formation of mountains. Yet, what truly drives this massive geological engine? Scientists believe that the heat from the core is the primary force behind this motion, but the dynamics of plate tectonics are still not entirely understood. How Earth maintains such a delicate balance between destruction and creation remains a subject of ongoing study. Then there are the oceans, which cover over 70% of Earth's surface and contain more secrets than we have begun to uncover. The depths of the ocean are as mysterious as space itself, with creatures adapted to conditions that are more extreme than those found on the surface of distant planets. The Mariana Trench, the deepest part of the ocean, plunges to depths of nearly 36,000 feet. The immense pressure at these depths is akin to that found on the surface of Venus, yet life still thrives in these dark, crushing environments. Could the life forms that exist here provide clues to what might exist elsewhere in our solar system? On moons like Europa and Enceladus, where similar conditions may prevail beneath icy crusts. Earth's atmosphere, thin and fragile compared to the vastness of space, is a dynamic system that not only supports life, but also shields the planet from harmful solar radiation. The interplay between the atmosphere and the sun's energy drives weather patterns and climate systems that we are only beginning to understand in their full complexity. From the mysterious origins of Earth's water to the ongoing cycles that regulate the carbon dioxide in our atmosphere, the Earth's climate holds keys to understanding life elsewhere in the universe. The study of Earth's greenhouse effect, for instance, has informed our understanding of the runaway greenhouse conditions observed on Venus, offering a cautionary tale about the fragility of planetary ecosystems. The story of Earth is not just about the present or the distant past. It's also a story about the future. We are living in an era where human activity has become a geological force in its own right. The Anthropocene, as some scientists call it, represents a new chapter in Earth's history, where the actions of a single species, humans, are reshaping the planet on a scale that rivals natural forces. From the melting of polar ice caps to the acidification of the oceans, the changes we are causing may reverberate for millions of years. Yet, Earth has shown remarkable resilience in the face of past cataclysms, from asteroid impacts to supervolcanic eruptions. Understanding how Earth has recovered from such events in the past can provide insight into the future of our planet and whether it will continue to sustain life as we know it. One of the most profound questions about Earth is its place in the cosmos. Earth's location within the habitable zone of the Sun, often referred to as the Goldilocks zone, has long been thought of as a key factor in the development of life. Not too hot, not too cold, This region allows liquid water to exist, a crucial ingredient for life as we understand it. But recent discoveries suggest that Earth's unique conditions might not be as rare as once thought. There are now thousands of known exoplanets orbiting stars in distant solar systems, many of which may lie within their own habitable zones. Yet, none of these exoplanets have been confirmed to host life. Why? Then, did Earth alone develop the complex ecosystems and biodiversity we see today? Earth's biodiversity itself is one of its greatest mysteries. Life on Earth exploded into existence around 3.5 billion years ago, and since then, it has evolved into an astonishing variety of forms, from the smallest microbes to the largest mammals. Yet, the forces that drive evolution and extinction are still not fully understood. Mass extinctions have wiped out nearly all life on Earth multiple times, and each time, life has bounced back in different and more complex forms. How life continues to adapt and thrive in the face of environmental changes is a testament to the resilience of biological systems. But it also raises questions about the limits of this resilience. Could life on Earth survive another mass extinction, especially one caused by human activity? The secrets of Earth extend beyond the physical and biological realms. Human civilizations have risen and fallen over the millennia, leaving behind ruins that offer glimpses into the mysteries of our own species. From the construction of the pyramids to the disappearance of entire cultures like the Maya, human history is filled with enigmas that reflect our own quest for understanding. But as we unlock these historical secrets, we are also confronted with the sobering reality that our future on this planet is fragile. Our technological advances have given us unprecedented power to shape the Earth, but they have also made us vulnerable to the consequences of our actions. In the end, the secrets of Earth are not just about understanding the planet itself. They are about understanding our place in the universe. Earth is our only home, a rare and precious world in a vast and largely hostile cosmos. It is a planet that has sustained life for billions of years, yet its future is uncertain. As we continue to explore the mysteries of our world, we must also confront the reality that the choices we make today will determine the fate of future generations. The secrets of Earth may never be fully unraveled, but they remind us that our connection to the cosmos is both intimate and fragile. And as we look to the stars for answers about the origins of life and the nature of the universe, we must not forget that the most profound secrets may still lie beneath our feet, in the core of the Earth, in the depths of the ocean, and in the air we breathe. The quest to understand Earth is, in many ways, the quest to understand everything. The secrets of Earth continue to captivate and challenge our understanding, particularly when we consider its past and the forces that have shaped its current form. One of the most astonishing revelations about our planet is the dramatic and often violent history that has played out over billions of years. Long before humans walked the surface, Earth was a volatile, chaotic world, bombarded by comets and asteroids, with its crust constantly shifting and reforming. The study of Earth's geological past reveals a planet in constant flux, shaped by catastrophic events that have often led to mass extinctions, followed by periods of remarkable regeneration and transformation. The most well-known of these events is perhaps the asteroid impact that caused the extinction of the dinosaurs 66 million years ago. This cataclysmic event, which created the massive Chicxulub crater in modern-day Mexico, wiped out nearly 75% of all life on Earth at the time. Yet this was far from the only mass extinction event in Earth's history. The Permian-Triassic extinction, which occurred 252 million years ago, was even more devastating, eradicating 96% of all marine species and 70% of terrestrial species. What caused such widespread destruction? Scientists believe a combination of massive volcanic eruptions, climate change, and possibly asteroid impacts contributed to this great dying. But the true mechanisms remain a puzzle, and studying them could provide critical clues about the resilience of life and the future of our planet under current environmental pressures. What is remarkable is that after each mass extinction, life on Earth has not only rebounded, but has often flourished in new and unexpected ways. Following the extinction of the dinosaurs, for example, mammals, previously small and relatively insignificant, rose to dominance, eventually leading to the emergence of humans. This ability of life to adapt and thrive in the face of adversity is one of Earth's most intriguing secrets. Evolution, driven by natural selection, is a process we understand in principle, but the specific factors that lead to the rise and fall of different species are still the subject of much research. Why do some species survive mass extinctions while others do not? And how does life find new forms in the wake of such devastation? The history of life on Earth is also closely tied to the movement of its continents. The concept of plate tectonics, developed in the 20th century, revolutionized our understanding of Earth's surface. The idea that the continents are not fixed, but instead drift across the surface of the planet was once considered radical. But now we know that this slow but powerful process has dramatically shaped Earth's geography and climate over millions of years. Pangaea, the supercontinent that existed during the late Paleozoic and early Mesozoic eras, eventually broke apart, leading to the formation of the continents as we know them today. But what drives this movement of tectonic plates, and what role has it played in shaping the course of life on Earth? It turns out that the movements of continents are not just geological phenomena. They have had profound impacts on the evolution of species and ecosystems. As landmasses separated and collided over time, species were isolated or introduced to new environments, leading to diversification and sometimes extinction. The shifting of continents also affects global climate patterns, altering ocean currents and atmospheric circulation. This, in turn, can trigger ice ages or periods of extreme warmth, further influencing the course of evolution. Today, the continents are still moving, albeit at a rate of only a few centimeters per year, but over millions of years, this will continue to reshape the face of the planet. But the secrets of Earth are not just hidden in the deep past. They are also present in the complex systems that govern life today. One of the most fascinating and least understood of these systems is the biosphere, the global sum of all ecosystems. Earth is the only planet we know of that has such a diverse and interconnected web of life, from the tiniest microorganisms to the largest animals. The way these organisms interact with each other and with their environment is crucial to the health of the planet. For example, the role of bacteria in recycling nutrients like nitrogen and carbon is essential for maintaining the balance of Earth's ecosystems. Without these microscopic workers, life as we know it could not exist. Yet, despite their importance, we still know very little about many of the organisms that inhabit our planet. It is estimated that we have only identified a fraction of the species that exist on Earth, particularly in remote and extreme environments like the deep ocean or dense rainforests. Every year, new species are discovered, some of which challenge our understanding of biology and life itself. Some organisms, like extremophiles, creatures that thrive in extreme conditions, are particularly intriguing because they raise questions about the potential for life on other planets. If life can exist in the boiling hot springs of Yellowstone or the freezing depths of Antarctica, could similar life forms exist on other planets with extreme environments? This brings us to another of Earth's secrets, its role as a model for understanding the potential for life elsewhere in the universe. The search for extraterrestrial life has long fascinated humanity, but much of what we know about the conditions necessary for life comes from studying Earth. The discovery of extremophiles, for instance, has expanded our understanding of where life could potentially exist, suggesting that life might not be limited to Earth-like conditions. In recent years, the discovery of water ice on Mars and evidence of liquid oceans beneath the icy crusts of moons like Europa and Enceladus has fueled speculation that life could exist elsewhere in our solar system. But while the search for life beyond Earth captures the imagination, it also raises profound questions about the uniqueness of our own planet. If we do find life elsewhere, what will that mean for our understanding of Earth's place in the cosmos? Earth has long been seen as a rare oasis of life in a vast and empty universe. But if life is more common than we once thought, what does that say about the conditions that make Earth special? Alternatively, if life is found to be exceedingly rare, it may highlight just how extraordinary and precious our planet truly is. The relationship between Earth and the cosmos goes beyond the search for life. Earth itself is part of a dynamic and interconnected system with the rest of the solar system and beyond. The Sun, for instance, plays a crucial role in shaping Earth's climate and weather. Solar flares and coronal mass ejections can disrupt Earth's magnetic field, causing geomagnetic storms that affect everything from satellite communications to power grids. On a larger scale, the Sun's gradual increase in luminosity over billions of years will eventually make Earth uninhabitable, long before it expands into a red giant and engulfs the inner planets. Even beyond the Sun, Earth is influenced by the gravitational forces of other planets and objects in the solar system. The Moon, Earth's closest celestial neighbor, has a particularly profound effect on the planet. The Moon's gravitational pull creates the tides, which have played a crucial role in the development of life on Earth. Some scientists believe that the Moon's stabilizing influence on Earth's axial tilt has helped to maintain a relatively stable climate over millions of years, making life possible. Without the Moon, Earth might be a much more volatile and inhospitable place. As we delve deeper into the mysteries of Earth, it becomes clear that the planet is far from an isolated system. It is part of a much larger cosmic dance, influenced by forces both near and far. Understanding these forces is not just about understanding the past or present. It's about preparing for the future. The more we learn about Earth's interactions with the cosmos, the better equipped we will be to face the challenges that lie ahead, both on this planet and beyond. As we continue to unravel the secrets of planet Earth, one of the most striking realizations is just how interconnected all the forces at play are, both seen and unseen. Earth is a living system, where everything from the smallest microbe to the tallest mountain is part of a dynamic, ever-evolving network. And yet, some of the most fascinating aspects of this system are those we can't perceive directly with our senses. Forces and phenomena that remain hidden until we develop the tools or the perspective to understand them. One such hidden force is gravity, a fundamental, yet often overlooked player in Earth's story. Gravity is the invisible force that holds us to the planet's surface, but its effects go far beyond this simple fact. The gravitational pull of the Earth governs the flow of water and rivers, the rise and fall of the tides, and even the shape of our planet itself, which is not a perfect sphere, but rather an oblate spheroid, slightly flattened at the poles and bulging at the equator due to its rotation. While we often take gravity for granted, without it, life on Earth would be impossible. Yet gravity also holds mysteries of its own. For example, scientists are still working to understand variations in Earth's gravitational field caused by the distribution of mass within the planet. These subtle differences, known as gravitational anomalies, can reveal much about the structure of the Earth's interior, as well as past geological events. Another unseen, but incredibly powerful force at work on Earth is the energy we receive from the sun's solar radiation is the driving force behind weather systems, ocean currents, and much of the energy flow within ecosystems. Without the sun's light and heat, Earth would be a frozen, lifeless rock drifting through space. However, the sun's influence is not constant. Solar activity follows an 11-year cycle, during which the frequency of solar flares and sunspots rises and falls. These fluctuations in solar energy can have significant impacts on Earth's climate, sometimes contributing to periods of warming or cooling. Scientists are still studying the complex relationship between solar activity and Earth's climate, trying to understand how these natural cycles interact with human-induced climate change. But solar energy is not the only source of power influencing Earth. The planet itself is a storehouse of tremendous geothermal energy, which emanates from its hot core. This internal heat is responsible for phenomena such as volcanic eruptions, earthquakes, and the movement of tectonic plates. Volcanoes, in particular, have played a critical role in shaping the surface of the Earth and even its atmosphere. During massive eruptions, volcanoes release vast amounts of gases and particles into the atmosphere, which can affect global temperatures by blocking sunlight. The eruption of Mount Tambora in 1815, for example, led to the year without a summer, causing widespread crop failures and food shortages. On a larger scale, volcanic activity over millions of years has been instrumental in regulating Earth's carbon cycle, helping to keep the planet's climate in balance. The deep interior of Earth remains one of its most enigmatic realms. Despite advances in technology, we have only scratched the surface, literally and figuratively, when it comes to understanding what lies beneath the crust. The core of the Earth, made primarily of iron and nickel, is believed to generate the planet's magnetic field through a process known as the geodynamo. This magnetic field acts as a shield, protecting Earth from the solar wind and cosmic radiation that could strip away our atmosphere and make life impossible. Yet, the inner workings of the core are still shrouded in mystery. Scientists know that the magnetic field has flipped many times throughout Earth's history, with the north and south magnetic poles swapping places. These geomagnetic reversals, though well documented in the geological record, remain poorly understood. We don't know exactly what triggers these reversals, how long they take to occur, or what the effects on the planet might be during such a transition. Even closer to the surface, Earth's crust holds secrets that can tell us much about the planet's past and future. Fossil records embedded in rock layers give us snapshots of ancient ecosystems, revealing how life on Earth has evolved over time. Plate tectonics, the slow movement of the Earth's crustal plates, constantly reshapes the planet's surface, creating mountains, ocean basins, and continents. Over millions of years, the positions of the continents have changed dramatically, leading to the breakup of supercontinents like Pangaea and the formation of new landmasses. This process continues today, although at a rate too slow for humans to notice on a day-to-day basis. However, the consequences of plate tectonics can be sudden and catastrophic, as seen in the form of earthquakes and volcanic eruptions. These events remind us that while Earth's surface may seem stable, it is always in motion. Water, too, plays a crucial role in shaping Earth's surface and sustaining life. Earth is often called the blue planet because of its vast oceans, which cover more than 70% of its surface. Yet, the origin of Earth's water remains one of the great mysteries of planetary science. Some theories suggest that water was delivered to Earth by icy comets and asteroids during the planet's early history, while others propose that water may have been present in the dust and gas cloud from which the planet formed. However it arrived, water has been essential to the development of life on Earth and continues to drive key processes such as weathering, erosion, and the water cycle. The oceans are also home to some of the most biodiverse ecosystems on the planet, many of which remain unexplored. Deep-sea trenches, hydrothermal vents, and other extreme environments harbor life forms that could hold clues to how life began on Earth, and perhaps how it might exist elsewhere in the universe. One of the most extraordinary aspects of Earth is its atmosphere, a thin layer of gases that sustains life and regulates the planet's climate. Composed primarily of nitrogen and oxygen, the atmosphere also contains trace amounts of carbon dioxide, water vapor, and other gases that are essential to life. The atmosphere shields us from harmful ultraviolet radiation from the sun, and its composition has changed dramatically over the course of Earth's history. Early in the planet's history, the atmosphere was dominated by volcanic gases with little oxygen. It wasn't until photosynthetic organisms evolved and began releasing oxygen as a byproduct that the atmosphere transformed into the oxygen-rich environment we depend on today. The balance of gases in the atmosphere is delicate, and human activity is currently altering this balance in ways that could have profound consequences. The burning of fossil fuels, deforestation, and industrial processes are releasing large amounts of carbon dioxide and other greenhouse gases into the atmosphere, contributing to global warming and climate change. These changes are already affecting ecosystems, weather patterns, and sea levels, and they could lead to more severe impacts in the coming decades. Understanding how Earth's climate has changed in the past, during ice ages, periods of extreme heat, and times of rapid change, is crucial to predicting what might happen in the future. Yet, despite all these forces at work, both natural and human-induced, Earth continues to be a remarkably resilient planet. The complex interplay of its systems has allowed life to not only survive, but thrive for billions of years. Life on Earth has endured asteroid impacts, volcanic supereruptions, ice ages, and mass extinctions, adapting to each new challenge. This resilience raises intriguing questions about the potential for life to endure on other planets or moons. If Earth, with all its challenges, can support such a diverse array of life forms, what might we find on worlds like Mars, Europa, or even exoplanets orbiting distant stars? The more we learn about Earth, the more we realize how much remains unknown. From the deep oceans to the outer atmosphere, from the core to the magnetic field, Earth is a planet full of surprises. And as we continue to explore both our own world and others in the cosmos, Earth remains the best laboratory we have for understanding the possibilities of life and the processes that shape planets. Every discovery on Earth, every secret unlocked, brings us one step closer to answering the ultimate questions about our place in the universe. As we delve deeper into the mysteries of planet Earth, one of the most intriguing areas of study lies at the intersection of biology and geology. Life on Earth has been inextricably linked to the planet's geological processes since the very beginning. From the evolution of organisms in the primordial oceans to the flourishing of complex ecosystems on land, the story of life is intertwined with the changing landscapes and climates that have shaped Earth's surface. But this connection goes beyond the physical. It also reveals how life itself has, in turn, influenced the planet's geology, creating a delicate and intricate dance between the living and non-living systems. One of the most remarkable examples of life's influence on Earth is the Great Oxygenation Event, which occurred around 2.4 billion years ago. Before this period, Earth's atmosphere was primarily composed of methane, ammonia, and other gases hostile to most modern life forms. However, the advent of cyanobacteria, tiny microorganisms capable of photosynthesis, began to change everything. These early life forms released oxygen as a byproduct of their metabolic processes, gradually increasing the concentration of oxygen in the atmosphere. This monumental shift not only made Earth more hospitable to life as we know it, but also had a profound effect on the planet's geology, leading to the formation of new types of minerals and influencing the oxidation of metals in the Earth's crust. The rise of oxygen in Earth's atmosphere was not without its consequences. It triggered what is sometimes called the oxygen crisis, as the buildup of oxygen led to the extinction of many anaerobic organisms that could not survive in the new oxygen-rich environment. This mass extinction event, which is often overlooked in discussions about Earth's history, highlights the profound impact that living organisms can have on their environment. In this case, life itself altered the course of evolution, paving the way for the development of more complex, oxygen-dependent life forms, including eventually plants and animals. The relationship between life and the planet extends beyond the atmosphere and into the very crust of the Earth. Microorganisms play a vital role in processes such as soil formation, nutrient cycling, and even the breakdown of rocks. These microbes, many of which live in extreme environments deep beneath the surface, help to regulate the carbon cycle by absorbing carbon dioxide and releasing it back into the atmosphere. Without these microscopic workers, Earth's climate and ecosystems would likely be vastly different. Yet, despite their importance, much of this subterranean biosphere remains a mystery. Scientists estimate that a significant portion of Earth's total biomass may be hidden underground, locked away in the rocks and sediments beneath our feet. These deep-dwelling organisms, some of which thrive in conditions of intense pressure and heat, could offer new insights into the potential for life on other planets, particularly those with similarly extreme environments. One of the key geological features that has shaped both the physical and biological history of Earth is its volcanic activity. Volcanoes are often thought of as destructive forces, spewing lava and ash across the landscape. However, they also play a crucial role in creating the conditions necessary for life. Volcanic eruptions release gases such as carbon dioxide and water vapor into the atmosphere, which help to regulate the planet's temperature and contribute to the greenhouse effect. Over geological time, volcanic activity has been responsible for forming much of Earth's landmass and creating the fertile soils that support agriculture and ecosystems today. Volcanoes have also been linked to some of Earth's most significant mass extinction events. For instance, the Siberian Traps, a massive volcanic region in what is now Russia, is believed to have contributed to the Permian-Triassic extinction event, the most severe extinction in Earth's history. The eruptions released vast amounts of carbon dioxide and sulfur dioxide into the atmosphere, leading to global warming, ocean acidification, and the collapse of ecosystems. Yet, even in the aftermath of such cataclysmic events, life has found a way to rebound. The resiliency of life in the face of such destruction is a testament to the adaptability of biological systems, and it raises questions about how life on Earth might respond to future environmental changes, both natural and human-induced. Another geological process that has played a critical role in shaping life on Earth is the cycling of carbon through the planet's various systems. The carbon cycle involves the movement of carbon between the atmosphere, oceans, soil, and living organisms. Carbon is the backbone of all life, and the balance of carbon in Earth systems is essential for maintaining the planet's climate and ecosystems. Over long periods, carbon is stored in rocks and sediments, only to be released again through volcanic activity or the weathering of rocks. This cycle has been in place for billions of years, helping to regulate Earth's temperature and support life. However, human activities, particularly the burning of fossil fuels, have disrupted this delicate balance, leading to an increase in atmospheric carbon dioxide levels and contributing to global climate change. This disruption of the carbon cycle is a stark reminder of how closely intertwined Earth's natural systems are and how vulnerable they can be to human influence. The impact of human activity on the planet has become so pronounced that many scientists now argue we are living in a new geological epoch, the Anthropocene. This term refers to the era in which humans have become a dominant force shaping Earth's geology and ecosystems. From deforestation and urbanization to the pollution of the oceans and atmosphere, humanity's influence is now visible across the planet. While some of these changes, such as habitat destruction and biodiversity loss, are cause for concern, others, like the development of new technologies to mitigate environmental damage, offer hope for the future. In the midst of these changes, Earth continues to reveal new and unexpected secrets. One of the most exciting areas of discovery in recent years has been the study of Earth's extremophiles, organisms that thrive in conditions once thought to be uninhabitable. These remarkable creatures can survive in environments of extreme heat, cold, pressure, or acidity, such as hydrothermal vents on the ocean floor, hot springs, or deep underground caves. The existence of extremophiles has expanded our understanding of the limits of life and has opened up new possibilities in the search for life beyond Earth. If organisms can thrive in such extreme conditions here on Earth, it raises the question of whether life could also exist in the harsh environments of other planets or moons, such as Mars or the icy moons of Jupiter and Saturn. In addition to extremophiles, recent discoveries in the field of astrobiology have drawn attention to the possibility that life on Earth might not be as isolated as we once thought. The theory of panspermia suggests that life, or at least the building blocks of life, could have been transported to Earth from elsewhere in the universe, carried by comets or meteorites. While this idea remains speculative, it challenges the traditional view that life originated solely on Earth and opens the door to the possibility that life could exist elsewhere in the cosmos, waiting to be discovered. Even as we search for life beyond Earth, the secrets of our own planet continue to offer new insights into the fundamental processes that govern the universe. Earth is, after all, a part of the cosmic puzzle. Its atmosphere, oceans, and landscapes are shaped by the same physical laws that govern the formation of stars and galaxies. By studying Earth, we gain a deeper understanding not only of our own planet, but of the forces that shape all planets, and perhaps even the universe itself. In the end, the secrets of planet Earth remind us of the profound connection between life and the cosmos. Earth is a unique and dynamic world, shaped by forces both seen and unseen, known and unknown. As we continue to explore its mysteries, we are reminded that our planet is part of a much larger story, a story that stretches across space and time, linking us to the stars and beyond. Earth may be our home, but it is also our gateway to understanding the universe. As we continue our journey into the mysteries of planet Earth, we must also consider the incredible diversity of environments that exist on this singular world. From the frozen polar regions to the vast deserts, from the deepest ocean trenches to the highest mountain peaks, Earth's varied landscapes hold countless secrets. Each environment presents unique challenges and conditions, yet life has adapted and thrived in even the most extreme places, revealing the planet's remarkable capacity for sustaining a wide range of ecosystems. These diverse habitats offer a window into the resilience and adaptability of life, and they also raise questions about how these ecosystems will continue to function in the face of ongoing environmental changes. The polar regions of Earth, for example, are among the most extreme environments on the planet. The Arctic and Antarctic are characterized by their frigid temperatures, long periods of darkness, and ice-covered landscapes. Yet, life persists here in forms both familiar and alien. Polar bears, penguins, seals, and other animals have evolved to survive the harsh conditions, while beneath the ice, microscopic life forms thrive in subglacial lakes and oceans. These creatures have adapted to survive in complete darkness and freezing temperatures, often by developing unique metabolic processes that allow them to extract energy from their environment in ways that are still not fully understood. The study of life in these extreme environments provides not only insights into the limits of life on Earth, but also clues about the potential for life on icy worlds elsewhere in the solar system, such as Europa or Enceladus. One of the greatest mysteries of the polar regions is the role that the ice itself plays in regulating Earth's climate. The polar ice caps reflect a significant portion of the sun's energy back into space, helping to cool the planet. This phenomenon, known as the albedo effect, is crucial for maintaining the balance of Earth's climate. However, as global temperatures rise due to human-induced climate change, the polar ice is melting at an alarming rate. This not only contributes to rising sea levels, but also reduces the reflective surface area, allowing more heat to be absorbed by the planet. Scientists are closely monitoring the polar regions as they are on the front lines of climate change, and understanding the dynamics of ice melt and its long-term effects on global climate is a critical area of research. Shifting our focus to the opposite end of the environmental spectrum, Earth's deserts present another extreme yet life-sustaining environment. Deserts, characterized by their arid conditions and dramatic temperature swings, are often seen as barren and inhospitable. Yet, they are home to a surprising variety of life. Plants and animals in deserts have developed extraordinary adaptations to conserve water and survive the intense heat of the day and the freezing temperatures of the night. For example, some cacti can store water for months, while certain desert animals like the kangaroo rat can survive without ever drinking water, obtaining all the moisture they need from their food. Deserts also play a significant role in Earth's ecological and atmospheric systems. Dust storms originating in desert regions, particularly the Sahara, can transport vast quantities of minerals and nutrients across oceans and continents. These dust clouds can fertilize distant ecosystems, including the Amazon rainforest, by depositing essential nutrients that promote plant growth. At the same time, these dust storms can affect weather patterns and contribute to atmospheric warming by scattering sunlight and trapping heat. The study of deserts, therefore, offers insights not only into the survival of life in extreme environments, but also into the interconnectedness of Earth systems, where even the most remote and desolate places can influence global processes. Another environment that reveals Earth's secrets is found at its highest elevations, mountain ranges. These towering formations, which have been shaped by the slow but powerful forces of tectonic activity, are not only majestic landscapes but also vital ecosystems. Mountains are often referred to as water towers because they store vast amounts of fresh water in the form of snow and glaciers. This water is gradually released during warmer months, feeding rivers and providing a critical water supply to billions of people around the world. The Himalayas, the Andes, the Rockies. Each mountain range plays a crucial role in regulating regional climates, supporting biodiversity, and sustaining human populations. Yet, mountains are also vulnerable to the impacts of climate change. Glaciers in many of the world's mountain ranges are retreating at unprecedented rates, threatening the freshwater supplies of entire regions. This glacier melt not only contributes to rising sea levels, but also increases the risk of natural disasters such as landslides and floods. The ecosystems of mountains, which are often rich in biodiversity and home to species found nowhere else on Earth, are also under threat as temperatures rise and habitats shift. The study of mountain environments offers valuable insights into how climate change is reshaping Earth's landscapes and the urgent need to protect these vital regions. While deserts and mountains reveal the extremes of Earth's surface environments, the oceans take us to an entirely different realm of exploration, one that is both vast and largely unexplored. Covering more than 70% of Earth's surface, the oceans are the planet's most important and least understood environment. The deep ocean, in particular, remains one of the last great frontiers of exploration. Despite advances in technology, we have explored only a tiny fraction of the ocean floor, and much of the deep ocean is still a mystery. What we do know, however, is that the deep ocean is home to some of the most bizarre and fascinating life forms on the planet. Organisms living in the deepest parts of the ocean, such as the Mariana Trench, must withstand immense pressures, complete darkness, and near-freezing temperatures. Yet, these creatures have evolved unique adaptations, such as bioluminescence, to survive in such harsh conditions. Hydrothermal vents, which spew superheated water rich in minerals, support entire ecosystems that are completely independent of sunlight, relying instead on chemosynthesis, a process by which microorganisms convert chemical energy into organic matter. The discovery of life around hydrothermal vents has revolutionized our understanding of the potential for life in extreme environments and has raised intriguing questions about where life could exist elsewhere in the universe. If life can thrive in the dark, high-pressure conditions of the deep ocean, it opens up the possibility that similar ecosystems could exist beneath the icy surfaces of moons like Europa, where subsurface oceans may be heated by tidal forces and volcanic activity. The oceans also play a critical role in regulating Earth's climate and supporting life on a global scale. They act as a massive carbon sink, absorbing a significant portion of the carbon dioxide emitted into the atmosphere, which helps to mitigate the effects of climate change. However, this process is not without its consequences. As oceans absorb more carbon dioxide, they become more acidic, which threatens marine ecosystems, particularly coral reefs. Coral reefs, often referred to as the rainforests of the sea, are among the most diverse and productive ecosystems on Earth, supporting thousands of species. Yet, they are highly sensitive to changes in temperature and acidity. As ocean temperatures rise and acidity levels increase, coral reefs are experiencing widespread bleaching and die-offs, which could have cascading effects on marine biodiversity and the human communities that depend on them. As we explore the depths of the oceans, the peaks of mountains, the expanses of deserts, and the icy realms of the poles, it becomes clear that Earth's environments are as diverse as they are interconnected. The challenges these environments face, particularly in the context of climate change, highlight the delicate balance that sustains life on our planet. Human activities are increasingly disrupting this balance, and the consequences of these disruptions are becoming more apparent with each passing year. Yet, there is still much we can learn from Earth systems, lessons that may help us mitigate the impacts of environmental changes and preserve the planet's remarkable diversity for future generations. Earth's environments, from the surface to the deepest ocean trenches, continue to hold secrets that challenge our understanding and push the boundaries of science. As we uncover these secrets, we are reminded of the complexity and fragility of the systems that sustain life. Every discovery deepens our appreciation of the planet and our responsibility to protect it. The more we learn about Earth, the more we realize that its story is far from complete. Each environment, each ecosystem, and each organism contributes to the rich tapestry of life, offering clues about the planet's past and its potential future. As we continue to explore, we are not only unlocking the secrets of Earth, but also gaining a deeper understanding of our place within the vast and intricate web of life. As we continue our exploration of planet Earth, we are drawn deeper into the unseen forces that govern the planet's behavior, particularly those that lie beneath the surface. While the landscapes we see, from towering mountains to expansive oceans, reveal the beauty and diversity of Earth, much of the planet's true nature is hidden underground, where dynamic processes have been at work for billions of years. These subterranean realms hold the key to understanding how Earth has evolved, and they provide insight into the forces that will continue to shape the planet's future. At the heart of Earth's internal structure lies its molten core, a region of extreme heat and pressure that drives many of the planet's most powerful forces. The core, composed primarily of iron and nickel, is divided into two parts, a solid inner core and a liquid outer core. The movement of molten metal in the outer core generates Earth's magnetic field, a protective shield that extends far into space and guards the planet from harmful solar and cosmic radiation. This magnetic field is vital for maintaining Earth's atmosphere and protecting life from the harsh conditions of space. However, the behavior of the core is far from static. The movement of molten iron and the shifting of Earth's magnetic field are ongoing processes, and the magnetic field itself is subject to periodic reversals, where the magnetic poles swap places. These geomagnetic reversals have occurred many times throughout Earth's history, and while scientists understand that these reversals are a natural part of the planet's dynamo process, they are still unraveling the full implications of such events. One of the most remarkable aspects of Earth's magnetic field is how it connects our planet to the Sun. The interaction between Earth's magnetosphere and the solar wind, a stream of charged particles emitted by the Sun, creates stunning natural phenomena like the auroras or northern and southern lights. These light displays occur when solar particles collide with atoms in Earth's atmosphere, causing them to emit light. Beyond their beauty, auroras are a visible reminder of the constant interplay between Earth and the broader solar system. The magnetic field also plays a critical role in shielding satellites and space missions from radiation, ensuring that human technology and exploration can continue safely. However, during periods of intense solar activity, such as solar storms or coronal mass ejections, the magnetic field can be temporarily disrupted, leading to geomagnetic storms that affect communications, navigation systems, and even power grids on Earth. Beneath the crust, the mantle is another region of great mystery and importance. This layer of semi-solid rock extends about 2,900 kilometers below the surface and is in constant motion due to the heat emanating from the core. The mantle's slow, convective currents are responsible for the movement of tectonic plates on Earth's surface, a process that leads to the creation and destruction of continents, ocean basins, and mountain ranges. Tectonic activity is one of the primary forces that shape the planet's surface, but it also plays a key role in regulating the carbon cycle and maintaining Earth's climate over geological timescales. For example, when tectonic plates collide, they can trigger volcanic eruptions that release gases like carbon dioxide into the atmosphere, while the weathering of mountains formed by these collisions can help draw carbon dioxide out of the atmosphere, providing a natural feedback mechanism that stabilizes global temperatures. Volcanism, one of the most dramatic expressions of tectonic activity, has a profound impact on both Earth's geology and climate. Volcanoes have shaped the surface of Earth since its formation, and they continue to be agents of both creation and destruction. Over time, volcanic eruptions have created entire islands and mountain ranges, as well as providing the fertile soils that support agriculture and biodiversity in many regions. However, the impact of volcanic eruptions extends far beyond their immediate surroundings. Large-scale eruptions can inject massive amounts of ash and sulfur dioxide into the atmosphere, which can reflect sunlight and cause global cooling for several years. The eruption of Mount Pinatubo in 1991, for example, lowered global temperatures by about 0.5 degrees Celsius for several years, providing a stark reminder of the potential for volcanic activity to alter Earth's climate on a large scale. Yet, despite the significant role that tectonic and volcanic activity plays in shaping Earth's surface, these forces also reveal a planet that is far from peaceful. Earthquakes, another consequence of the movement of tectonic plates, are sudden releases of energy that occur when plates slip along fault lines. These seismic events can be devastating, causing widespread destruction and loss of life, especially in densely populated regions. Scientists have made great strides in understanding the mechanics of earthquakes and identifying areas at risk, but predicting when and where the next major quake will occur remains one of the greatest challenges in geology. Earthquakes serve as a reminder that while Earth's surface may seem stable, it is constantly in motion, and the forces at work beneath our feet can change the landscape in an instant. The study of earthquakes and tectonic activity has also led to the discovery of another hidden realm beneath Earth's surface, the deep subsurface biosphere. Recent research has revealed that vast microbial ecosystems exist several kilometers below the surface, thriving in the cracks and pores of rocks under extreme conditions of heat, pressure, and darkness. These microorganisms, known as extremophiles, survive by metabolizing minerals and gases from the surrounding rock, independent of sunlight. This discovery has expanded our understanding of where life can exist and has profound implications for the search for life on other planets. If life can thrive in the extreme environments deep within Earth, it raises the possibility that similar life forms could exist beneath the surface of other planets or moons, such as Mars or Europa, where subsurface habitats may offer refuge from harsh surface conditions. The interplay between Earth's internal processes and its surface environments is further highlighted by the phenomenon of plate tectonics, which not only creates land masses but also plays a role in their eventual destruction. The concept of the rock cycle, where rocks are continuously recycled through processes such as erosion, sedimentation, and subduction, shows how Earth's surface is constantly being reshaped by both internal and external forces. As tectonic plates move and collide, they generate mountain ranges, but over time, these mountains are worn down by wind, water, and ice, only to be uplifted again as tectonic forces continue their slow but inexorable march. This constant recycling of Earth's materials is a testament to the planet's dynamic nature and its ability to sustain life by continuously renewing its landscapes. Another critical aspect of Earth's internal processes is the role they play in regulating the planet's climate over long time scales. The movement of tectonic plates affects the distribution of continents, which in turn influences ocean currents and atmospheric circulation patterns. These large-scale changes have played a significant role in driving Earth's ice ages and periods of warming, as the position of continents can block or redirect ocean currents, altering the distribution of heat around the globe. Additionally, the weathering of rocks, driven by tectonic uplift, helps to remove carbon dioxide from the atmosphere, a process that has contributed to the cooling of the planet over millions of years. As we study the forces beneath Earth's surface, it becomes clear that the planet is a highly interconnected system where geological processes, climate, and life are all intertwined. The dynamic nature of Earth's interior, from the molten core to the shifting tectonic plates, drives many of the processes that shape the surface and regulate the planet's environment. Understanding these processes is not only crucial for predicting natural disasters like earthquakes and volcanic eruptions, but also for grasping the long-term changes that influence Earth's climate and ecosystems. The secrets of Earth's interior reveal a planet that is both resilient and constantly evolving. The forces at work deep beneath the surface, while invisible to us on a day-to-day basis, are fundamental to the continued existence of life and the maintenance of Earth's habitability. As scientists continue to explore and uncover the mysteries of Earth's inner workings, we gain a deeper appreciation for the complex and dynamic planet we call home. It is a reminder that while we may live on the surface, much of what makes life on Earth possible occurs far below, in the molten heart of the planet and the shifting layers of rock that make up its structure. In this ongoing journey to understand Earth, we are also reminded that the planet's internal processes have been active for billions of years, far longer than the human species has existed. The forces that shape our world today are the same forces that shaped it in the distant past, and they will continue to shape it long after we are gone. As we strive to understand these forces, we not only unlock the secrets of Earth's past, but also glimpse the future of our ever-changing world. As we continue to explore the hidden forces shaping planet Earth, another fundamental aspect comes into focus: the intricate relationship between Earth's atmosphere, oceans, and life itself. These interconnected systems have not only shaped the planet's environment, but have also played a critical role in the evolution of life over billions of years. Each system operates in a delicate balance, and even small changes can lead to profound shifts in Earth's climate, ecosystems, and the conditions necessary to sustain life. Understanding how these systems work together provides insight into Earth's past, present, and future, and the ongoing changes we are witnessing today. One of the most important components of Earth's climate system is its atmosphere, a thin layer of gases that envelopes the planet and regulates its temperature. The atmosphere is primarily composed of nitrogen and oxygen, but it also contains trace amounts of carbon dioxide, methane, water vapor, and other gases, many of which are critical for maintaining Earth's climate. Without the atmosphere, Earth would be a lifeless, barren world, similar to the Moon or Mars. The atmosphere not only traps heat from the sun, creating a stable climate, but it also protects life from harmful ultraviolet radiation and cosmic rays. The importance of Earth's atmosphere cannot be overstated. It is a dynamic, protective blanket that sustains life in myriad ways. The interaction between Earth's atmosphere and its oceans is a key driver of the planet's climate system. Oceans cover more than 70% of Earth's surface and act as a massive reservoir for heat and carbon. The oceans absorb large amounts of solar energy, which is then redistributed around the planet by ocean currents. These currents play a crucial role in regulating global climate, influencing weather patterns and temperatures. For example, the Gulf Stream, a powerful ocean current that flows from the Gulf of Mexico across the Atlantic Ocean, carries warm water toward Europe, making its climate much milder than it would be otherwise. Disruptions to these ocean currents, caused by shifts in temperature or salinity, can have dramatic effects on global climate, as seen during events like El Niño and La Niña, which can alter weather patterns around the world. One of the most pressing challenges facing Earth's climate system today is the increasing concentration of greenhouse gases in the atmosphere, largely due to human activity. Carbon dioxide, methane, and other greenhouse gases trap heat within the atmosphere, leading to global warming. The burning of fossil fuels, deforestation, and industrial processes have significantly increased the levels of these gases since the Industrial Revolution, and their impact is becoming increasingly apparent. Global temperatures are rising, polar ice is melting, and weather patterns are becoming more extreme and unpredictable. The consequences of these changes are already being felt around the world, from more frequent and intense storms to rising sea levels that threaten coastal communities. The oceans, too, are feeling the effects of climate change. As atmospheric carbon dioxide levels rise, the oceans absorb much of this excess CO2, which leads to ocean acidification. This process makes the water more acidic, which has serious implications for marine life, particularly for organisms like corals, mollusks, and some plankton species that rely on calcium carbonate to build their shells and skeletons. As the water becomes more acidic, it becomes harder for these organisms to survive, threatening the delicate balance of marine ecosystems. Coral reefs, which are some of the most biodiverse ecosystems on the planet, are especially vulnerable to both acidification and rising temperatures. Coral bleaching, a phenomenon where corals expel the symbiotic algae living in their tissues due to stress from warmer waters, has been occurring with increasing frequency, leading to the degradation of reefs around the world. In addition to its role in regulating climate, the ocean is home to an astonishing array of life. The diversity of life in Earth's oceans is staggering, ranging from the tiniest microorganisms to the largest animals on the planet, like the blue whale. The ocean is a crucial component of Earth's biosphere, and many of the planet's ecosystems depend on the health of marine environments. Yet, much of the ocean remains unexplored. Despite advances in technology, the deep ocean, the vast, dark, and high-pressure environment that covers much of the planet, holds secrets that we are only beginning to uncover. Scientists estimate that up to 80% of the ocean floor remains unmapped, and the discovery of new species in the deep sea is a regular occurrence. One of the most exciting discoveries in recent years has been the realization that life can exist in the most extreme conditions, far beyond the reach of sunlight. Hydrothermal vents on the ocean floor, which emit superheated, mineral-rich water, support entire ecosystems that are independent of the sun's energy. Instead of photosynthesis, these ecosystems rely on chemosynthesis, a process in which bacteria and other microorganisms convert chemicals like hydrogen sulfide into organic matter. This discovery has fundamentally changed our understanding of the conditions necessary for life and has led to new ideas about where life might exist elsewhere in the solar system, such as on the icy moons of Jupiter and Saturn. The oceans also play a critical role in the carbon cycle, which is the process by which carbon is exchanged between the atmosphere, oceans, and living organisms. Phytoplankton, tiny marine plants, are responsible for absorbing large amounts of carbon dioxide through photosynthesis. These organisms form the base of the oceanic food chain and are crucial to the health of marine ecosystems. When they die, some of the carbon they have absorbed sinks to the ocean floor, where it can be stored for long periods in sediments. This process, known as the biological carbon pump, helps to regulate the amount of carbon dioxide in the atmosphere and plays a significant role in mitigating climate change. Despite the importance of oceans and the atmosphere in maintaining Earth's climate and supporting life, these systems are highly vulnerable to human activity. Pollution, overfishing, and habitat destruction are placing immense pressure on marine ecosystems. Plastic pollution, in particular, has become a global crisis, with millions of tons of plastic waste entering the oceans each year. This pollution harms marine life, from the smallest plankton to the largest whales, and disrupts the balance of marine ecosystems. Efforts to address ocean pollution and protect marine environments are underway, but much more needs to be done to safeguard the future of Earth's oceans. Another critical component of Earth's interconnected systems is the water cycle, which governs the movement of water between the atmosphere, oceans, rivers, lakes, and land. The water cycle is essential for distributing fresh water around the planet, supporting both ecosystems and human civilizations. Rainfall replenishes rivers and lakes, which provide drinking water, irrigation for crops, and habitats for countless species. However, the water cycle is also being affected by climate change. In some regions, changing weather patterns are leading to more frequent and severe droughts, while in others, heavier rainfall and flooding are becoming more common. The melting of glaciers and ice sheets, which store vast amounts of fresh water, is also contributing to rising sea levels and altering the flow of water in many regions. The interplay between Earth's atmosphere, oceans, and the biosphere is not just about maintaining the planet's climate. It also influences the evolution of life. The conditions on Earth have changed dramatically over the planet's history, from periods of intense warmth to ice ages where glaciers covered much of the land. Life has evolved in response to these changing conditions, and the fossil record reveals how different species adapted, migrated, or went extinct in response to shifts in climate and geography. The current period of rapid climate change presents a new challenge for life on Earth, as species struggle to adapt to the increasingly unstable environment. One of the most striking examples of how climate and life are interconnected is the role that forests play in regulating the atmosphere. Forests, particularly tropical rainforests, act as the lungs of the planet, absorbing carbon dioxide through photosynthesis and releasing oxygen into the atmosphere. Forests also help to regulate local climates by absorbing heat, generating moisture, and supporting the water cycle. However, deforestation, driven by logging, agriculture, and urban expansion, is threatening these vital ecosystems. The destruction of forests not only reduces biodiversity, but also releases stored carbon back into the atmosphere, exacerbating climate change. Protecting and restoring forests is therefore crucial for both preserving biodiversity and mitigating global warming. The study of Earth's atmosphere, oceans, and ecosystems reveals a planet that is in constant motion, shaped by complex and interdependent processes. As we continue to learn more about these systems, we gain a deeper understanding of the challenges facing the planet in the 21st century. Climate change, pollution, habitat loss, and overexploitation of resources are putting immense pressure on Earth's natural systems, and the consequences of these changes are becoming increasingly clear. Yet, even as we confront these challenges, Earth's resilience offers hope. The planet has experienced dramatic changes throughout its history, and life has found ways to adapt and thrive. By understanding the interconnected nature of Earth systems, we can work to restore balance and protect the delicate web of life that sustains us. The more we learn about our planet's secrets, the more we realize that its future depends on our actions today. As stewards of Earth, it is our responsibility to preserve its rich biodiversity, protect its climate, and ensure that the systems that sustain life can continue to function for generations to come. As we delve even further into the secrets of planet Earth, we begin to focus on the extraordinary forces that govern the cycles of life and matter. One of the most critical yet often overlooked systems on Earth is the biosphere, the global network of life that spans from the deepest ocean trenches to the highest mountain peaks. The biosphere is more than just a collection of ecosystems. It is a living, breathing system that interacts with Earth's atmosphere, hydrosphere, and geosphere in complex ways. Understanding how the biosphere operates and evolves is crucial to comprehending Earth's ability to sustain life and adapt to environmental changes. At the core of the biosphere's function are biogeochemical cycles, the processes that recycle nutrients and elements like carbon, nitrogen, oxygen, and phosphorus through the Earth systems. These cycles are vital for sustaining life because they ensure that essential elements are available in forms that organisms can use. The carbon cycle, for example, regulates the flow of carbon through the atmosphere, oceans, soil, and living organisms. Carbon is the building block of life, and without the constant cycling of carbon through photosynthesis, respiration, and decomposition, life as we know would not be possible. One of the key components of the carbon cycle is photosynthesis, the process by which plants, algae, and some bacteria convert carbon dioxide from the atmosphere into organic matter using sunlight. This process not only provides the foundation for nearly all life on Earth, but also plays a critical role in regulating the planet's climate. Forests, grasslands, and oceans act as carbon sinks, absorbing vast amounts of carbon dioxide and helping to mitigate the effects of climate change. However, human activities like deforestation and the burning of fossil fuels are disrupting the carbon cycle, releasing stored carbon back into the atmosphere and accelerating global warming. Protecting and restoring natural carbon sinks is therefore essential for maintaining the balance of the carbon cycle and addressing the challenges of climate change. The nitrogen cycle is another fundamental system that sustains life on Earth. Nitrogen is a key component of proteins, DNA, and other essential molecules, but most of the nitrogen in the atmosphere is in a form that plants and animals cannot use directly. Nitrogen-fixing bacteria, which live in the soil and in the roots of certain plants, convert atmospheric nitrogen into forms that can be absorbed by plants. These plants, in turn, provide the nitrogen that animals need to build their own tissues. When plants and animals die, decomposers break down their organic matter, returning nitrogen to the soil, where it can be used again. This continuous recycling of nitrogen is vital for maintaining the fertility of ecosystems and supporting the growth of plants, which form the basis of most food chains. Human activities, however, have greatly altered the nitrogen cycle, particularly through the use of synthetic fertilizers in agriculture. While fertilizers have increased food production and supported the growth of human populations, they have also led to widespread environmental problems. Excess nitrogen from agricultural runoff can enter rivers, lakes, and oceans, causing nutrient pollution that leads to harmful algal blooms and dead zones, areas where oxygen levels are too low to support most marine life. These disruptions to the nitrogen cycle highlight the delicate balance that must be maintained to sustain healthy ecosystems and ensure the availability of essential nutrients for future generations. Phosphorus, another critical element for life, is cycled through the biosphere in much the same way as nitrogen. Phosphorus is essential for the formation of DNA, cell membranes, and energy-carrying molecules like ADP, making it a crucial component of all living organisms. Unlike carbon and nitrogen, phosphorus is not found in significant quantities in the atmosphere. Instead, it is primarily stored in rocks and is released slowly through weathering. Once in the soil, phosphorus is absorbed by plants and passed through the food chain. However, like nitrogen, the overuse of phosphorus-based fertilizers has led to environmental problems, particularly in freshwater ecosystems, where excess phosphorus can cause algal blooms and disrupt the balance of aquatic life. These biogeochemical cycles are not only critical for sustaining life, but also for maintaining the health and stability of Earth's ecosystems. The interplay between living organisms and the physical environment creates a dynamic system where matter is constantly recycled and energy flows through the food web. At the base of this system are primary producers, plants, algae, and some bacteria that capture energy from the sun through photosynthesis. This energy is then passed through the food web, from herbivores to predators, in a continuous flow that sustains life at all levels of the ecosystem. One of the most profound aspects of Earth's biosphere is its diversity. The variety of life on Earth, from the smallest microorganisms to the largest mammals, is astonishing. Biodiversity is not just about the number of species, but also the complexity of interactions between them. Ecosystems are made up of countless species that rely on one another for food, shelter, and other resources. These interactions create a web of life that is both resilient and fragile. Biodiversity helps ecosystems withstand disturbances, such as natural disasters or changes in climate, because a greater variety of species can fulfill different ecological roles. However, when biodiversity is lost, ecosystems become more vulnerable to collapse, as they lose the redundancy and adaptability needed to respond to environmental stress. Today, biodiversity is under threat on a global scale. Habitat destruction, pollution, climate change, and overexploitation of resources are driving species to extinction at rates far higher than the natural background rate. The loss of biodiversity is not just a tragedy for the species that disappear. It also has far-reaching consequences for the ecosystems that depend on them and for the humans who rely on those ecosystems for food, water, and other resources. Tropical rainforests, coral reefs, and wetlands are among the most biodiverse ecosystems on Earth, and they are also some of the most threatened. Protecting these ecosystems is critical not only for preserving biodiversity, but also for maintaining the services they provide, from carbon sequestration to water filtration and food production. One of the most striking examples of the interconnectedness of Earth's systems is the role of the oceans in supporting life both in the water and on land. The oceans are the largest ecosystem on Earth, and they play a crucial role in regulating the planet's climate and providing resources for human societies. Phytoplankton, tiny marine plants, form the base of the oceanic food web and are responsible for producing roughly half of the oxygen in Earth's atmosphere. These microorganisms also play a key role in the carbon cycle, absorbing carbon dioxide through photosynthesis and helping to regulate the planet's temperature. However, the health of the oceans is increasingly threatened by human activities. Overfishing, pollution, and climate change are all taking a toll on marine ecosystems. Coral reefs, which support a quarter of all marine species, are particularly vulnerable to rising ocean temperatures and acidification caused by increased carbon dioxide levels. Coral bleaching events, where corals expel the symbiotic algae that provide them with energy, are becoming more frequent as ocean temperatures rise, leading to the degradation of these vital ecosystems. The loss of coral reefs would not only devastate marine biodiversity, but also impact millions of people who depend on them for food, tourism, and coastal protection. The interaction between Earth's biosphere and its physical environment is also evident in the water cycle, which connects ecosystems across the planet. Water is essential for life, and the cycling of water through evaporation, condensation, precipitation, and runoff sustains ecosystems and regulates the planet's climate. Forests, wetlands, and rivers all play critical roles in maintaining the water cycle. Forests, for example, help to generate rainfall by releasing moisture into the atmosphere through a process known as transpiration. Wetlands act as natural water filters, removing pollutants from water and helping to regulate water flow, reducing the risk of floods and droughts. However, human activities are disrupting the water cycle in many regions of the world. Deforestation, particularly in tropical rainforests, is reducing the ability of forests to generate rainfall, leading to drier conditions in some areas. The draining of wetlands for agriculture and development is reducing the planet's ability to filter water and mitigate floods. Climate change is also altering precipitation patterns, leading to more intense storms in some regions and prolonged droughts in others. These changes are putting additional pressure on ecosystems and the humans who depend on them for freshwater. In light of these challenges, understanding and preserving Earth's biosphere is more important than ever. The biosphere is a living system that has evolved over billions of years, shaped by the forces of natural selection, climate, and geology. It is a system that sustains life in all its forms, from the smallest bacteria to the largest mammals, and it is a system that is increasingly under threat from human activities. By studying the biosphere and the cycles that sustain it, we can learn how to protect and restore the planet's ecosystems and ensure that they continue to function for future generations. The secrets of planet Earth are not just hidden in its physical structures or geological processes. They are also found in the delicate balance of life that has developed over millennia. The interplay between Earth's atmosphere, oceans, and biosphere is a testament to the complexity and resilience of life, but it is also a reminder of how vulnerable these systems are to disruption. As we continue to explore and understand Earth's interconnected systems, we gain the knowledge needed to protect the planet and the life it supports. Our future depends on maintaining this balance, not just for the survival of individual species, but for the health of the entire planet. As we continue our exploration of the intricate systems that govern planet Earth, we turn our attention to one of the most mysterious and profound aspects of our planet: the deep time of Earth's geological history and the forces that have shaped it over billions of years. Earth's surface may seem stable to us on human timescales, but in the vast stretches of geological time, the planet has been in constant flux. Continents drifting, mountains rising, oceans forming and disappearing, and life itself evolving through cycles of creation and destruction. The concept of deep time refers to the mind-boggling expanse of Earth's history, which stretches back roughly 4.5 billion years. Understanding deep time is essential for grasping the true scale of the changes that have shaped the planet, many of which unfold over millions or even billions of years. It is within this framework of deep time that we begin to comprehend the forces that sculpted the land, gave rise to mountains, split continents, and sparked life. Through the study of geology, paleontology, and climate science, we can peer into Earth's past, reconstructing the dramatic events that have led to the world we live in today. One of the most important drivers of change over deep time is plate tectonics, the slow movement of Earth's crustal plates that has continuously reshaped the planet's surface. The idea of plate tectonics, which was only fully accepted in the 20th century, revolutionized our understanding of Earth's dynamic nature. The planet's crust is divided into large plates that float on the semi-fluid layer of the mantle below. These plates are in constant motion, though they move only a few centimeters each year. Over millions of years, however, this movement has profound effects, shaping the continents, creating mountain ranges, opening and closing oceans, and triggering volcanic activity and earthquakes. The movement of tectonic plates is responsible for some of Earth's most dramatic features, such as the formation of the Himalayas, the tallest mountain range on the planet. The Himalayas were created by the collision of the Indian plate with the Eurasian plate, a process that began around 50 million years ago and continues to this day. This collision caused the crust to buckle and fold, pushing up the towering peaks that we see today. Similarly, the Atlantic Ocean was born when the supercontinent Pangaea began to break apart around 200 million years ago, as the tectonic plates drifted apart, creating new ocean basins. The theory of plate tectonics also helps to explain the phenomenon of continental drift, the idea that the continents have not always been in their current positions. In fact, Earth's continents have come together and broken apart multiple times over the planet's history, forming supercontinents like Pangaea, Rodinia, and Gondwana. These massive landmasses existed for hundreds of millions of years before they fractured and drifted into the positions we recognize today. The process of continental drift has played a crucial role in shaping Earth's climate and biodiversity. As continents moved closer to or farther from the equator, they experienced different climate conditions, which affected the evolution of life. The isolation of continents also led to the evolution of unique species in different regions. contributing to the planet's biodiversity. Volcanic activity is another force that has dramatically shaped Earth's surface and played a pivotal role in the evolution of life. Volcanoes are not only responsible for creating new land masses, such as the Hawaiian Islands, but they have also influenced the planet's climate over deep time. Massive volcanic eruptions can release enormous amounts of ash and sulfur dioxide into the atmosphere, which can temporarily block sunlight and cool the planet. These events, known as volcanic winters, have occurred multiple times in Earth's history and have had significant impacts on global climate and ecosystems. The eruption of the Siberian Traps, a large volcanic province in Russia, around 252 million years ago, is believed to have contributed to the Permian-Triassic extinction, the most severe extinction event in Earth's history, which wiped out about 96% of all marine species and 70% of terrestrial species. Mass extinction events are another critical aspect of deep time that has shaped the course of life on Earth. Over the past 500 million years, Earth has experienced 5 major mass extinctions, during which large percentages of species were wiped out in relatively short periods of time. These events were caused by a variety of factors, including volcanic activity, asteroid impacts, and dramatic shifts in climate. Each mass extinction marked the end of entire ecosystems and the beginning of new evolutionary pathways as surviving species adapted to the altered environment. The most famous of these mass extinctions is the Cretaceous-Paleogene extinction, which occurred around 66 million years ago and led to the demise of the dinosaurs. This extinction event was triggered by the impact of a massive asteroid that struck the Yucatan Peninsula in modern-day Mexico, creating the Chicxulub crater. The impact released an enormous amount of energy, causing wildfires, tsunamis, and a nuclear winter effect as dust and debris blocked sunlight, drastically cooling the planet. While the dinosaurs and many other species were wiped out, this event paved the way for mammals to rise to dominance, eventually leading to the evolution of humans. However, it's important to recognize that mass extinctions, while catastrophic, also create opportunities for new forms of life to emerge. After each extinction event, Earth has experienced periods of rapid evolution known as adaptive radiations, during which surviving species diversify and fill ecological niches left vacant by the extinctions. The aftermath of the Cretaceous-Paleogene extinction, for example, saw the rapid evolution of mammals, which diversified into a wide range of forms and eventually gave rise to primates and, much later, humans. The fossil record is a window into the deep history of life on Earth, providing us with a detailed record of how life has evolved in response to changes in the planet's environment. Fossils, the preserved remains of ancient organisms, allow scientists to trace the development of species over millions of years, revealing patterns of evolution, extinction, and adaptation. The discovery of transitional fossils, which show features of both ancestral and descendant species, has provided crucial evidence for the theory of evolution. For example, the fossil of Archaeopteryx, a transitional species between dinosaurs and modern birds, shows how flight evolved in certain groups of theropod dinosaurs. Earth's climate has also undergone dramatic changes over deep time, oscillating between periods of extreme warmth and glaciation. The planet has experienced several ice ages, during which large portions of the continents were covered in glaciers. These glacial periods, known as snowball Earth events, had a profound impact on the evolution of life, as many species adapted to the cold while others went extinct. Between ice ages, Earth has also experienced periods of intense warmth, known as greenhouse periods, during which tropical conditions extended to higher latitudes. These shifts in climate were driven by a variety of factors, including changes in Earth's orbit, volcanic activity, and the concentration of greenhouse gases in the atmosphere. One of the most significant climate shifts in Earth's history occurred around 2.5 billion years ago during the Great Oxygenation Event. Before this event, Earth's atmosphere contained little oxygen, and life was dominated by anaerobic microorganisms. However, the evolution of cyanobacteria, which produced oxygen through photosynthesis, gradually increased the amount of oxygen in the atmosphere. This dramatic change not only transformed Earth's climate, but also allowed for the evolution of more complex, oxygen-dependent life forms. The rise of oxygen in the atmosphere also led to the formation of the ozone layer, which protects life from harmful ultraviolet radiation and made it possible for life to colonize land. The interplay between life and the environment over deep time is a central theme in Earth's history. Life itself has played a key role in shaping the planet's environment, just as the environment has shaped the evolution of life. For example, the proliferation of plants during the Carboniferous period, around 300 million years ago, dramatically altered Earth's atmosphere by removing large amounts of carbon dioxide and increasing oxygen levels. This change in atmospheric composition allowed for the evolution of larger, more complex animals and contributed to the formation of vast coal deposits, which are the fossilized remains of ancient forests. Today, humanity is becoming a significant force in shaping the planet, leading many scientists to propose that we are entering a new geological epoch, the Anthropocene. This term refers to the period in Earth's history during which human activity has become the dominant influence on climate, ecosystems, and geology. The rapid industrialization of the past 2 centuries has altered the carbon cycle, driven the mass extinction of species, and transformed landscapes through deforestation, agriculture, and urbanization. The Anthropocene represents a profound shift in Earth's history, as human actions now rival natural forces in shaping the planet's future. The study of deep time not only helps us understand the forces that have shaped Earth's past, but also provides crucial insights into the challenges we face in the present. By understanding how the planet has responded to dramatic changes in the past, whether caused by asteroid impacts, volcanic eruptions, or shifts in the carbon cycle, we can gain a better understanding of how Earth might respond to the changes we are causing today. The lessons of deep time remind us that Earth is resilient but also vulnerable, and that the actions we take now will shape the planet for millions of years to come. In this vast narrative of deep time, Earth reveals itself not as a static, unchanging world, but as a dynamic and evolving planet, constantly reshaped by powerful forces and the life that inhabits it. The secrets of Earth's deep history continue to unfold as we explore its rocks, study its fossils, and unlock the mysteries of its past. And as we look forward to the future, we are reminded that the story of Earth is still being written. As we continue to explore the deep mysteries of planet Earth, our focus shifts to the forces that operate on a more immediate timescale, but are no less powerful or mysterious. These forces, ranging from atmospheric dynamics to the interaction between the Earth and space, reveal a planet constantly responding to external influences. Some of these processes, such as weather patterns and ocean currents, operate on a human timescale, while others, like the cyclical rhythms of the solar system, unfold over thousands or even millions of years. Together, these forces shape the environment we experience daily and connect Earth to the broader universe in ways that are still being discovered. One of the most fascinating aspects of Earth's immediate environment is its atmosphere, which plays a critical role in regulating the planet's climate and weather. Earth's atmosphere is a complex system of gases, primarily nitrogen and oxygen, along with trace amounts of water vapor, carbon dioxide, methane, and other gases. This thin layer of air not only sustains life by providing oxygen and regulating temperature, but also protects us from harmful solar radiation and space debris. The atmosphere is divided into several layers, each with its own unique properties. The lowest layer, the troposphere, is where weather occurs, while the stratosphere contains the ozone layer, which shields the planet from ultraviolet rays. One of the key processes that govern the behavior of Earth's atmosphere is the greenhouse effect, which is essential for maintaining the planet's habitable temperatures. When sunlight reaches Earth, some of the energy is absorbed by the surface, while the rest is reflected back into space. The Earth's surface then emits heat in the form of infrared radiation. Certain gases in the atmosphere, such as carbon dioxide, methane, and water vapor, trap some of this heat, preventing it from escaping back into space. This process warms the planet, making it possible for life to thrive. Without the greenhouse effect, Earth would be too cold to support life as we know it. However, human activity has significantly intensified the greenhouse effect by adding large amounts of greenhouse gases to the atmosphere, particularly carbon dioxide from the burning of fossil fuels. As a result, Earth's average temperature is rising, leading to global warming and climate change. This increase in temperature is disrupting weather patterns, altering ecosystems, and melting ice in polar regions, contributing to rising sea levels. Understanding the delicate balance of the greenhouse effect and its implications for the future is one of the greatest challenges facing scientists today. Earth's climate system is also profoundly influenced by the movement of air masses and the flow of energy between the atmosphere and the surface. Wind, driven by the uneven heating of Earth's surface, plays a crucial role in redistributing heat around the planet. The interaction between wind and ocean currents creates global weather patterns that affect everything from rainfall to temperature. One of the most well-known examples of this interaction is the El Niño Southern Oscillation, ENSO, a periodic climate phenomenon that occurs in the tropical Pacific Ocean. During an El Niño event, warmer than usual ocean temperatures disrupt normal weather patterns, leading to severe droughts in some regions and heavy rains and flooding in others. La Niña, the opposite phase of ENSO, typically brings cooler ocean temperatures and different climatic effects. These oscillations have far-reaching impacts on global weather and can cause economic and humanitarian challenges due to their effects on agriculture, fisheries, and water supplies. Another important aspect of Earth's climate system is the role played by the ocean, which acts as both a heat reservoir and a carbon sink. The oceans absorb about 90% of the heat from global warming, preventing the atmosphere from heating up even more rapidly. However, this also means that the oceans are warming, leading to thermal expansion and the melting of ice sheets and glaciers, which contribute to rising sea levels. Additionally, the ocean absorbs a significant amount of carbon dioxide from the atmosphere, helping to mitigate the effects of climate change. However, as carbon dioxide levels rise, the ocean becomes more acidic, which has devastating effects on marine ecosystems, particularly coral reefs. The ocean's ability to absorb heat and carbon is driven in part by large-scale circulation patterns, such as the Atlantic Meridional Overturning Circulation, AMOC, sometimes referred to as the global conveyor belt. This system of currents transports warm water from the tropics to the poles and cold water from the poles back to the equator. The AMOC plays a key role in regulating global climate, particularly in the North Atlantic region. However, there is growing concern that this circulation system is weakening due to the melting of polar ice and the influx of fresh water into the North Atlantic. A slowdown of the AMOC could have dramatic consequences for climate patterns, particularly in Europe and North America, where it helps moderate temperatures. In addition to these terrestrial processes, Earth is constantly influenced by external forces from space, particularly the Sun. The Sun is the ultimate source of energy for Earth's climate system, and variations in solar radiation can have significant effects on global temperatures. The Sun's energy output varies over an 11-year cycle, during which the number of sunspots increases and decreases. These variations can influence Earth's climate, though their effects are generally smaller compared to the influence of human activity. In rare cases, however, solar activity can have more immediate and noticeable impacts on Earth's environment. Solar flares and coronal mass ejections, CMEs, can release large bursts of energy and charged particles into space, which can interact with Earth's magnetic field and atmosphere, creating beautiful auroras, but also disrupting satellite communications, power grids, and GPS systems. Earth's magnetic field itself is a fascinating and still not fully understood aspect of the planet's interaction with space. Generated by the motion of molten iron in Earth's outer core, the magnetic field acts as a shield, protecting the planet from the solar wind, a stream of charged particles emitted by the Sun. Without this protective magnetic bubble, known as the magnetosphere, Earth's atmosphere could be gradually stripped away by the solar wind, as has happened on Mars. The magnetosphere also plays a crucial role in deflecting cosmic radiation, which poses a threat to both human health and electronics in space. One of the most intriguing mysteries related to Earth's magnetic field is the phenomenon of geomagnetic reversals, in which the planet's magnetic poles switch places. These reversals have occurred many times throughout Earth's history, with the most recent one taking place about 780,000 years ago. Although the mechanism driving these reversals is not fully understood, scientists believe that fluctuations in the flow of molten iron in Earth's core are responsible. While a geomagnetic reversal would not be catastrophic for life, it could disrupt satellite navigation, communications, and power systems, making it a topic of active research. In addition to solar and magnetic influences, Earth is constantly bombarded by meteoroids and asteroids, remnants from the early solar system. Most of these objects burn up in Earth's atmosphere, creating meteors, but larger ones occasionally make it to the surface, causing significant impacts. The most famous of these is the asteroid that struck Earth 66 million years ago, leading to the extinction of the dinosaurs. While large asteroid impacts are rare, they pose a serious threat to life on Earth, which is why scientists are working on strategies to detect and potentially deflect any future asteroid that might be on a collision course with our planet. One of the ways Earth has responded to impacts from space and other environmental challenges is through the evolution of life, which has continually adapted to changing conditions over millions of years. Life itself plays a fundamental role in shaping the planet's atmosphere and surface. The rise of oxygen-producing organisms during the Great Oxygenation event transformed the atmosphere, while the evolution of plants dramatically altered the landscape, driving changes in erosion, weathering, and soil formation. The Earth's biosphere, its web of life, has also had profound effects on the planet's carbon and nitrogen cycles. For instance, forests act as significant carbon sinks, absorbing carbon dioxide and helping to mitigate climate change. Similarly, nitrogen-fixing bacteria in the soil convert atmospheric nitrogen into forms that plants can use, supporting agriculture and ecosystems. However, human activities, particularly agriculture and industrialization, are altering these cycles in ways that are accelerating climate change and biodiversity loss. As we examine these interconnected systems, Earth's atmosphere, oceans, magnetic field, and its relationship with the sun and space, we begin to see a planet that is deeply integrated with both its internal processes and its cosmic environment. The Earth is not isolated, but exists in constant interaction with external forces that influence its climate, geology, and even life itself. In this grand narrative, human beings have emerged as a significant force of change, shaping the planet in ways that were previously the domain of natural processes. Our impact on the climate, ecosystems, and even the atmosphere is unprecedented in Earth's history, marking the dawn of a new geological epoch. The choices we make today, how we manage resources, protect ecosystems, and address climate change, will determine the trajectory of the planet for centuries, if not millennia, to come. As we look toward the future, understanding the delicate balance between Earth's systems and the external forces that influence them is critical. By studying the planet's past, we gain the tools to anticipate future changes, not just on Earth, but also in the broader context of the solar system. The secrets of Earth continue to reveal themselves, not just in the rocks beneath our feet or the stars above, but in the delicate, interconnected systems that sustain life and make our planet unique in the cosmos. As we continue our journey through the intricate systems that make planet Earth a unique and dynamic world, we now turn our attention to the fascinating phenomena that lie at the intersection of life, geology, and the cycles of time. The slow but profound processes of biological evolution and extinction, and their deep connection to Earth's changing environment. These processes are intertwined with Earth's geological transformations, illustrating how the history of life on this planet is inextricably linked to the forces shaping its surface, climate, and ecosystems. The evolution of life on Earth is one of the most remarkable stories in the history of the universe, beginning nearly 4 billion years ago when the first simple life forms emerged in Earth's primordial oceans. At that time, Earth was a very different place, with a toxic atmosphere and no complex organisms. Life is believed to have begun in the form of single-celled organisms, likely in deep-sea hydrothermal vents or shallow coastal environments where the right conditions for biochemical processes existed. These early life forms, known as prokaryotes, were remarkably resilient, able to survive in an environment with no oxygen. The rise of life had a profound effect on Earth's atmosphere and environment, particularly with the advent of photosynthesis around 2.4 billion years ago. Cyanobacteria, a type of bacteria that could capture sunlight and convert carbon dioxide into organic matter, began to release oxygen as a byproduct. This was a revolutionary development for both life and the planet, as it eventually led to the Great Oxygenation Event. This period, marked by the dramatic increase in atmospheric oxygen, transformed the Earth's environment and paved the way for more complex, oxygen-dependent organisms to evolve. At the same time, the rise of oxygen also led to one of the earliest mass extinction events, as many anaerobic organisms, those that thrived in oxygen-free environments, could not survive in the new, oxygen-rich world. The Great Oxygenation Event highlights one of the most fascinating aspects of Earth's history, the interplay between life and the environment. As life evolved, it continuously altered the planet's atmosphere, oceans, and land, creating feedback loops that further influenced the course of evolution. This dynamic relationship between life and the planet systems is one of the defining features of Earth, and it has been a driving force in the evolution of life for billions of years. With the rise of oxygen, Earth entered a new era of biological innovation, culminating in the evolution of eukaryotes, organisms with complex cells containing a nucleus and other organelles. Eukaryotes would eventually give rise to all multicellular life, including plants, animals, and fungi. The appearance of multicellular organisms marked a major turning point in Earth's evolutionary history, leading to an explosion of diversity and complexity in the biosphere. One of the most significant periods of biological innovation was the Cambrian explosion, which occurred around 540 million years ago. During this relatively short period, geologically speaking, most of the major groups of animals that we are familiar with today appeared. Fossils from the Cambrian period reveal a world teeming with life, from early arthropods and mollusks to the first vertebrates. This explosion of life is often referred to as the Big Bang of biology, as it represents the first time that complex ecosystems with predators, prey, and a wide variety of ecological niches developed. The Cambrian explosion was not an isolated event, but rather part of a larger pattern in Earth's history where life undergoes periods of rapid diversification following major environmental changes. These periods of evolutionary innovation are often followed by mass extinctions, which wipe out large numbers of species, but also create new opportunities for the survivors to diversify and adapt to new environments. This pattern of extinction and diversification has repeated itself many times over the course of Earth's history, shaping the evolution of life in profound ways. Mass extinctions are one of the most dramatic forces in the history of life on Earth, and they have played a pivotal role in determining which species survive and which disappear forever. While extinction is a natural part of life's cycle, mass extinctions are characterized by the sudden loss of a large percentage of Earth species in a relatively short period of time. There have been 5 major mass extinctions in Earth's history, each of which drastically altered the course of evolution. One of the most devastating mass extinctions was the Permian-Triassic extinction event, also known as the Great Dying, which occurred around 252 million years ago. This extinction wiped out approximately 96% of marine species and 70% of terrestrial species, making it the largest extinction event in Earth's history. The causes of this mass extinction are still debated, but many scientists believe it was triggered by massive volcanic eruptions in what is now Siberia, which released large amounts of carbon dioxide and other gases into the atmosphere. This led to global warming, ocean acidification, and widespread anoxia, a lack of oxygen, in the oceans, creating conditions that were inhospitable to most life forms. In the aftermath of the Permian-Triassic extinction, the surviving species evolved and adapted to the dramatically changed environment, leading to the rise of the dinosaurs and the early ancestors of mammals. The dinosaurs, which dominated Earth for over 160 million years, are perhaps the most famous example of how life can rebound and thrive following a mass extinction. During the Mesozoic era, the age of the dinosaurs, Earth was a warm, lush world with vast forests, shallow seas, and a wide variety of plant and animal life. However, the reign of the dinosaurs came to a sudden end around 66 million years ago during the Cretaceous-Paleogene (KPG) extinction event. This event, triggered by the impact of a massive asteroid near what is now the Yucatan Peninsula, caused a global catastrophe that wiped out the non-avian dinosaurs, along with many other species. The impact, which created the Chicxulub crater, released a tremendous amount of energy, sending debris into the atmosphere and blocking sunlight. This impact winter drastically cooled the planet and disrupted ecosystems around the world. In the wake of this extinction, mammals, once small and relatively insignificant, began to diversify and dominate the land, eventually leading to the evolution of primates and, much later, humans. The cycle of mass extinctions and subsequent evolutionary diversification has shaped the history of life on Earth, driving the rise and fall of entire groups of organisms. While these events are often seen as destructive, they also create opportunities for new forms of life to emerge and evolve. The resilience of life is one of Earth's most remarkable traits. After each catastrophe, life has found a way to adapt, evolve, and fill the ecological niches left behind by extinct species. Today, we are living through what many scientists consider to be the sixth mass extinction, driven largely by human activities. Habitat destruction, pollution, climate change, and overexploitation of resources are leading to the rapid loss of biodiversity across the planet. Unlike previous mass extinctions, which were caused by natural events such as asteroid impacts or volcanic eruptions, this extinction is being driven by a single species, humans. The loss of biodiversity has far-reaching consequences for ecosystems, as each species plays a unique role in maintaining the balance of life. The extinction of a single species can have a cascading effect on the entire ecosystem, leading to the collapse of food chains and the loss of ecosystem services that humans rely on, such as pollination, clean water, and fertile soil. Yet, even in the face of this biodiversity crisis, there is hope. Conservation efforts, habitat restoration, and sustainable practices are helping to protect and restore ecosystems around the world. The study of Earth's past extinctions and recoveries provides valuable lessons for the present, showing us how resilient life can be and how we might mitigate the effects of the current biodiversity crisis. While we cannot reverse the extinctions that have already occurred, we can work to protect the remaining biodiversity and ensure that future generations inherit a planet rich with life. In addition to the forces of extinction and evolution, another key factor in the history of life on Earth is the role of migration and dispersal. Over millions of years, species have migrated across continents, adapting to new environments and evolving into new forms. Continental drift, the movement of Earth's tectonic plates, has played a crucial role in this process, as the shifting positions of continents have opened and closed migration routes for species. For example, when North and South America were connected by the formation of the Isthmus of Panama around 3 million years ago, it allowed species from both continents to migrate and interact, leading to the Great American Biotic Interchange. This event reshaped the biodiversity of the Americas, as species from the north migrated south and vice versa. These migrations, along with changes in climate and geography, have contributed to the rich tapestry of life we see today. The movement of species across the globe has allowed for the mixing of gene pools, the evolution of new species, and the spread of ecosystems. Today, however, human activities such as habitat fragmentation and climate change are disrupting these natural migration patterns, making it more difficult for species to move and adapt to changing environments. Preserving migration corridors and protecting ecosystems are essential for allowing species to continue their evolutionary journeys in the face of environmental change. The story of life on Earth is a story of resilience, adaptation, and constant change. From the earliest single-celled organisms to the incredible diversity of life we see today, Earth's biosphere has been shaped by a complex interplay of geological, climatic, and biological forces. As we continue to explore the planet's deep history, we gain a greater appreciation for the fragility and resilience of life, and for the ways in which life and the planet itself are interconnected. In this ongoing narrative, humans have emerged as one of the most powerful forces shaping the future of life on Earth. Our ability to understand and influence the planet's systems gives us a unique responsibility to protect and preserve the natural world. By studying the past, we can learn how to navigate the challenges of the present and ensure a sustainable future for both humanity and the countless other species with which we share this planet. The secrets of planet Earth continue to reveal themselves, showing us that while life is fragile, it is also remarkably resilient, and that the future of life on Earth is in our hands. As we continue our exploration into the profound mysteries of planet Earth, we now turn our focus to one of the most critical and enigmatic relationships that govern life on this planet: the dynamic and powerful connection between Earth and the wider universe. While Earth may seem to be a stable, self-contained world, it is in fact a planet in constant interaction with the cosmos. From the energy we receive from the sun to the gravitational pull of the moon, and from the asteroid impacts that have shaped life to the invisible forces of dark matter and energy, Earth is deeply embedded in the fabric of the universe. The sun, as Earth's primary source of energy, plays a central role in nearly every process that sustains life on the planet. Solar radiation drives the weather, fuels photosynthesis, and powers the water cycle. Without the sun, Earth would be a cold, lifeless rock drifting through space. The sun's influence is felt on both short timescales, through daily weather patterns, and long timescales, as variations in solar energy affect Earth's climate. Solar activity, such as sunspots, solar flares, and coronal mass ejections, CMEs, can have direct effects on Earth's magnetic field, atmosphere, and even technology. The sun operates on an 11-year solar cycle, during which the number of sunspots, cooler areas on the sun's surface, fluctuates. These sunspots are associated with solar flares and CMEs, which can release massive bursts of energy into space. When these energetic particles collide with Earth's magnetosphere, they can create stunning auroras, but they can also disrupt satellite communications, GPS systems, and power grids. This interplay between the sun and Earth reminds us that our planet is constantly exposed to forces from beyond, and even small changes in solar activity can have significant consequences for life and technology. On longer timescales, changes in Earth's orbit and axial tilt, phenomena known as Milankovitch cycles, also influence the planet's climate. These cycles, which occur over tens of thousands to hundreds of thousands of years, are caused by gravitational interactions between Earth, the Moon, and other planets. The shape of Earth's orbit around the Sun shifts from nearly circular to slightly elliptical, while the planet's axial tilt changes, affecting the distribution of sunlight and the intensity of seasons. These cycles have been linked to the timing of Earth's ice ages, demonstrating how the cosmic forces acting on Earth have profound impacts on its climate and habitability. One of the most fascinating aspects of Earth's connection to the universe is its relationship with the Moon. The Moon is not only Earth's closest celestial neighbor, but also a crucial stabilizing force for the planet. The Moon's gravitational pull creates tides in Earth's oceans, which have shaped the planet's coastlines and played a key role in the evolution of marine life. Tides create dynamic environments in which organisms must adapt to the changing water levels, and tidal zones have been some of the most productive ecosystems on Earth. Without the Moon's influence, Earth's rotation and axial tilt would be much more chaotic, leading to erratic climate patterns that might make life as we know it impossible. The Moon's formation is also one of the great mysteries of planetary science. Most scientists believe the Moon was created as a result of a colossal impact between the early Earth and a Mars-sized body, sometimes referred to as Theia, around 4.5 billion years ago. The debris from this impact eventually coalesced to form the Moon. This giant impact hypothesis explains many of the Moon's features, including its composition, which is strikingly similar to Earth's outer layers, as well as the fact that Earth's axis is tilted, giving us seasons. The formation of the Moon was a defining event in Earth's history, one that profoundly shaped the planet's evolution and climate. Earth's relationship with the broader solar system has also been shaped by asteroid and comet impacts, some of which have had catastrophic effects on life. The most famous of these impacts is the asteroid that struck Earth 66 million years ago, leading to the mass extinction of the dinosaurs. This event dramatically altered the course of evolution, allowing mammals to rise to dominance and ultimately giving rise to humans. However, asteroid impacts are not confined to the distant past. Earth is constantly bombarded by space debris, though most of it burns up in the atmosphere before reaching the surface. Larger objects, though rare, pose a significant threat, and scientists are actively monitoring near-Earth objects, NEOs, to detect any potential impactors. The study of asteroid impacts reminds us that Earth's fate is intertwined with the movement of objects in the solar system, and that the planet is not immune to cosmic hazards. While the Sun, Moon, and asteroids are visible and tangible components of Earth's connection to the cosmos, there are also invisible forces at work that shape the universe and our planet's place within it. One of the most mysterious and fundamental of these forces is gravity, the force that governs the motions of celestial bodies and holds the solar system together. Gravity not only dictates the orbits of planets, moons, and asteroids, but also influences the structure and evolution of galaxies and the universe itself. Gravity is also responsible for one of the most enigmatic phenomena in astrophysics: black holes. These regions of space-time, where gravity is so strong that not even light can escape, challenge our understanding of the universe. Black holes are the remnants of massive stars that have collapsed under their own gravity, and they can grow by accreting matter and even merging with other black holes. While black holes are far removed from Earth, their existence raises profound questions about the nature of space, time, and the ultimate fate of the universe. Even more mysterious than black holes is the concept of dark matter and dark energy. These unseen forces make up about 95% of the universe's total mass energy content, yet they are invisible and undetectable through traditional means. Dark matter, which exerts gravitational forces, is believed to form the scaffolding upon which galaxies are built, while dark energy is thought to be responsible for the accelerated expansion of the universe. Though we cannot directly observe dark matter and dark energy, their presence is inferred from their gravitational effects on visible matter and the large-scale structure of the cosmos. While these cosmic forces seem far removed from Earth, they highlight the fact that our planet is part of a much larger and more complex universe than we can easily perceive. Earth's place in the universe is governed by the same fundamental forces that shape galaxies, stars, and planets. Understanding these forces not only deepens our knowledge of the cosmos, but also provides insight into the processes that have shaped Earth over billions of years. As we look beyond our solar system, we are also confronted with the profound question of whether Earth is unique in its ability to support life. The discovery of exoplanets, planets orbiting stars beyond our solar system, has opened up new possibilities in the search for extraterrestrial life. Since the first exoplanet was discovered in 1992, thousands of these distant worlds have been identified, and many of them lie in the so-called habitable zone of their parent stars, where conditions might allow for liquid water, a key ingredient for life as we know it. One of the most tantalizing prospects for discovering life beyond Earth is the possibility that some of these exoplanets may harbor conditions similar to those that existed on early Earth. Scientists are particularly interested in rocky planets that orbit within the habitable zones of stars, where temperatures are just right for liquid water to exist. Some of these planets may have atmospheres and climates that are conducive to the development of life. The search for biosignatures, chemical indicators of life, such as oxygen or methane in an exoplanet's atmosphere, is one of the key goals of modern astronomy. While the discovery of extraterrestrial life remains one of the great unanswered questions of science, it also raises profound philosophical questions about humanity's place in the universe. If life is common throughout the cosmos, then Earth may not be as unique as we once thought. But if life is exceedingly rare, then the conditions that led to the emergence of life on Earth become even more extraordinary. In our exploration of the cosmos, we are also beginning to consider the future of humanity in space. Advances in space exploration, such as the development of reusable rockets and plans for crewed missions to Mars, are bringing the prospect of interplanetary colonization closer to reality. The idea of humans living on other planets raises both technical and ethical challenges. How would we sustain life on Mars, a planet with a harsh environment, no breathable atmosphere, and limited resources? What responsibilities would we have toward any microbial life that might exist on Mars or other celestial bodies? As humanity looks beyond Earth for new frontiers, we are also confronted with the urgent need to protect the planet we currently inhabit. The challenges posed by climate change, environmental degradation, and the loss of biodiversity underscore the fragility of life on Earth. While the exploration of space is an exciting and important endeavor, it also serves as a reminder that Earth is a rare and precious world in a vast and largely inhospitable universe. The knowledge we gain from studying other planets and the cosmos may help us better understand and care for our own planet. Earth's connection to the universe is a profound and complex relationship, shaped by the same forces that govern the stars, planets, and galaxies. From the sun's life-giving energy to the gravitational interactions that shape the solar system, and from the cosmic hazards posed by asteroids to the mysterious forces of dark matter and dark energy, Earth is deeply embedded in the cosmic web. As we continue to explore both the universe beyond and the intricate systems that sustain life on Earth, we gain a deeper understanding of our place in the cosmos and of the delicate balance that makes life possible on this extraordinary planet. As we continue to unravel the extraordinary mysteries of planet Earth, our exploration now leads us to the concept of time and humanity's relatively brief existence within the vast chronology of the planet. The impact that humans have had on the Earth during this short period, especially over the last few centuries, has been nothing short of monumental. From the dawn of agriculture to the age of industrialization, humans have transformed landscapes, altered ecosystems, and harnessed the planet's resources in ways that have fundamentally changed the trajectory of Earth's natural systems. This transformation raises profound questions about our relationship with the environment, our role as stewards of the planet, and the lasting legacy of human activity on Earth's future. The rise of human civilization is deeply intertwined with the natural world. For most of human history, our ancestors lived in harmony with their environment, relying on the seasons, the availability of water, and the abundance of plant and animal life to sustain them. The earliest human societies were hunter-gatherers, moving with the rhythms of nature, following the migrations of animals and the growth cycles of plants. However, the development of agriculture around 10,000 years ago marked a turning point in humanity's relationship with the planet. With the advent of farming, humans began to exert greater control over their environment, domesticating plants and animals, and establishing permanent settlements. The agricultural revolution was the first of many major shifts that would enable humans to thrive in increasingly complex societies. The ability to produce surplus food allowed populations to grow, and with the rise of civilizations came the development of technology, trade, and culture. Yet this newfound control over the environment also came with consequences. As humans cleared forests for farmland, dammed rivers for irrigation, and built cities, they began to alter the natural systems that had governed the Earth for millions of years. This human-driven transformation of the environment, though gradual at first, laid the foundation for the much larger changes that would follow in the modern era. The Industrial Revolution, which began in the late 18th century, marks perhaps the most significant turning point in human history in terms of our impact on the planet. Fueled by advances in technology and the discovery of fossil fuels, industrialization transformed human society and accelerated the pace of environmental change. The ability to harness coal, oil, and natural gas for energy allowed for the rapid expansion of industries, transportation, and agriculture. Factories, powered by steam engines and later by electricity, began to produce goods on a scale previously unimaginable, and cities grew larger and more populous. However, the Industrial Revolution also marked the beginning of humanity's profound impact on Earth's climate and ecosystems. The burning of fossil fuels released vast amounts of carbon dioxide into the atmosphere, a greenhouse gas that traps heat and contributes to global warming. At the same time, the clearing of forests for agriculture and urban development reduced the planet's ability to absorb carbon dioxide through photosynthesis, further exacerbating the problem. The Industrial Age also brought about significant changes to Earth's water systems, as rivers were dammed and diverted for hydroelectric power and irrigation, altering the flow of freshwater ecosystems and disrupting the habitats of countless species. As industrialization spread across the globe, it led to what many scientists now call the Anthropocene, a proposed geological epoch in which humans have become the dominant force shaping the planet's environment. Unlike previous epochs, which were defined by natural forces such as tectonic activity or asteroid impacts, the Anthropocene is characterized by the profound influence of human activity on Earth's geology, atmosphere, and ecosystems. This epoch has seen dramatic increases in carbon emissions, the widespread use of synthetic chemicals, the large-scale extraction of natural resources, and the loss of biodiversity at an unprecedented rate. The consequences of this human-driven transformation are becoming increasingly apparent. Climate change, driven by the accumulation of greenhouse gases in the atmosphere, is already altering weather patterns, melting polar ice, and raising sea levels. Extreme weather events, such as hurricanes, droughts, and floods, are becoming more frequent and severe, with devastating impacts on human communities and ecosystems. Rising temperatures are also affecting species around the world, as many animals and plants struggle to adapt to the changing climate. Coral reefs, which are among the most diverse ecosystems on Earth, are particularly vulnerable to rising ocean temperatures, with coral bleaching events threatening to destroy entire reef systems. In addition to climate change, human activities have led to widespread habitat destruction, deforestation, and the depletion of natural resources. Forests, which play a critical role in regulating the planet's climate and supporting biodiversity, are being cleared at an alarming rate for agriculture, mining, and urban development. The destruction of forests not only contributes to climate change by releasing stored carbon dioxide, but also leads to the loss of habitat for countless species, many of which are already endangered. The fragmentation of ecosystems makes it more difficult for species to migrate and adapt to changing conditions, further increasing the risk of extinction. Biodiversity loss is one of the most pressing environmental challenges of our time. The Earth is currently experiencing what many scientists refer to as the sixth mass extinction, driven largely by human activities such as habitat destruction, pollution, overfishing, and climate change. Species are disappearing at rates that far exceed the natural background rate of extinction, and this loss of biodiversity has profound implications for ecosystems and human societies. Ecosystems rely on the interactions between species to function properly, and the loss of even a single species can have cascading effects throughout the food web. Biodiversity is also crucial for human well-being, providing essential services such as pollination, clean water, and fertile soil. However, alongside the challenges posed by human impact on the environment, there is also the potential for solutions and hope. Scientific advances, environmental awareness, and policy changes are helping to drive a global movement towards sustainability and environmental stewardship. Renewable energy technologies, such as solar and wind power, offer the promise of reducing our reliance on fossil fuels and cutting carbon emissions. Advances in agricultural practices, such as regenerative farming and agroforestry, are helping to restore ecosystems, improve soil health, and reduce the environmental footprint of food production. Conservation efforts are also making a difference in protecting and restoring ecosystems. National parks, wildlife reserves, and marine protected areas are providing safe havens for species, allowing them to recover from the pressures of habitat loss and overexploitation. International agreements, such as the Paris Agreement on Climate Change and the Convention on Biological Diversity, are bringing countries together to address global environmental challenges. While much work remains to be done, these efforts represent a growing recognition of the need to protect the planet's natural systems and ensure a sustainable future for both humans and the rest of life on Earth. One of the key challenges of the Anthropocene is finding a way to balance human development and economic growth with the need to protect the environment. As the global population continues to grow and the demand for resources increases, it is becoming increasingly clear that the current model of consumption and production is unsustainable. A shift toward a more circular economy, where resources are reused, recycled, and conserved, is essential for reducing the environmental impact of human activity. Technological innovations, such as advances in energy efficiency, waste management, and green infrastructure, are helping to pave the way for a more sustainable future. In addition to technological solutions, addressing the challenges of the Anthropocene requires a fundamental shift in how we view our relationship with the natural world. For much of human history, nature was seen as a resource to be exploited for human benefit. However, there is growing recognition that humans are part of a larger ecological system and that our well-being is closely tied to the health of the planet. This shift in perspective is reflected in movements such as environmental justice, which advocates for the fair and equitable distribution of environmental benefits and the protection of vulnerable communities from environmental harm. Education and awareness are also crucial for fostering a deeper understanding of the environmental challenges we face and inspiring action. Environmental education programs, public awareness campaigns, and grassroots movements are helping to empower individuals and communities to take action in their own lives, from reducing waste and conserving energy to advocating for policies that protect the environment. The rise of youth-led movements, such as Fridays for Future and the Global Climate Strikes, has brought a new sense of urgency to the fight against climate change, with young people demanding that world leaders take bold and immediate action to address the crisis. The story of humanity's relationship with the Earth is still being written, and the choices we make today will determine the future of the planet for generations to come. While the challenges we face are immense, there is also hope in the resilience of both human societies and the natural world. Earth has endured countless changes over its 4.5 billion-year history, from mass extinctions to climate shifts, and life has always found a way to adapt and thrive. The question now is whether we, as a species, can rise to the challenge of living in harmony with the planet that sustains us. As we look to the future, the path forward will require a combination of science, technology, policy, and collective action. The solutions to the environmental challenges of the Anthropocene exist, but they require a concerted effort from governments, businesses, and individuals to implement. By learning from the past, understanding the interconnectedness of Earth systems, and embracing new ways of thinking about our place in the world, we can chart a course toward a more sustainable and equitable future. In this ongoing journey of discovery, planet Earth continues to reveal its secrets, not just through the study of its natural systems and history, but also through the challenges it presents to humanity in the modern age. The fate of the planet is, in many ways, in our hands, and the actions we take will shape the world for future generations. As stewards of this incredible planet, we have the power to protect and preserve the beauty, diversity, and life that Earth sustains, ensuring that its wonders continue to inspire and sustain life for millennia to come. As we venture deeper into the ongoing saga of planet Earth, our exploration brings us to the present moment, where humanity faces a critical turning point. The challenges of the Anthropocene, the era in which human activity has become the dominant force shaping Earth's climate and ecosystems, are now at the forefront of global consciousness. From unprecedented climate change to mass biodiversity loss, we are living in an age where the future of the planet and life on it depends on the actions we take today. Understanding the scale and urgency of these issues is crucial as we navigate the complexity of our impact on the planet and seek paths toward a sustainable and resilient future. At the center of the current environmental crisis is climate change. Driven primarily by the burning of fossil fuels, coal, oil, and natural gas, climate change is reshaping the planet in ways that are already becoming visible. Global temperatures have risen by more than 1 degree Celsius, 1.8 degrees Fahrenheit, since the late 19th century, and the consequences of this warming are being felt around the world. Glaciers are melting, sea levels are rising, and extreme weather events, such as hurricanes, floods, heat waves, and wildfires, are becoming more frequent and severe. The Arctic, which is warming at twice the rate of the rest of the planet, is experiencing unprecedented ice melt, which not only threatens local ecosystems, but also accelerates global warming by reducing the reflective ice cover that helps to cool the planet. One of the most immediate and visible impacts of climate change is the rise in sea levels. As glaciers and ice sheets melt, and as warmer water expands, sea levels are rising, putting coastal cities and communities at risk. Some of the world's largest and most densely populated cities, such as New York, Tokyo, and Mumbai, are located in low-lying coastal areas and are particularly vulnerable to flooding. For small island nations, such as the Maldives and Kiribati, rising sea levels pose an existential threat, as entire islands could be submerged, displacing populations and wiping out cultures and ways of life. This crisis highlights the global nature of climate change. It does not respect borders, and its effects are felt in every corner of the planet. In addition to sea level rise, the disruption of weather patterns caused by climate change is leading to more frequent and intense storms, droughts, and heat waves. The increasing intensity of tropical storms and hurricanes, driven by warmer ocean temperatures, is already causing devastating damage to coastal communities. In other parts of the world, prolonged droughts are leading to water shortages, threatening agriculture, and increasing the risk of wildfires. Heat waves, which have become more frequent and severe, are not only a public health crisis, but also have far-reaching impacts on agriculture, ecosystems, and infrastructure. The interconnected nature of Earth systems means that these changes are felt far beyond the regions directly affected, as disruptions to food production, water supplies, and economies ripple across the globe. The effects of climate change are particularly pronounced in ecosystems that are already under stress from human activity. Coral reefs, often referred to as the rainforests of the sea, due to their incredible biodiversity, are especially vulnerable to rising ocean temperatures. When water temperatures rise, corals expel the symbiotic algae that live within their tissues, leading to coral bleaching. Without these algae, corals lose their primary source of energy and can die. Large-scale coral bleaching events have already decimated coral reefs around the world, threatening the millions of species that rely on them for habitat and food. The loss of coral reefs also has significant implications for coastal communities that depend on reefs for fishing, tourism, and protection from storm surges. The loss of biodiversity is another critical aspect of the environmental crisis. Human activity, through habitat destruction, pollution, overfishing, and climate change, is driving species to extinction at rates far above the natural background rate. Scientists estimate that up to 1 million species are currently at risk of extinction, a loss that would have profound consequences for ecosystems and humanity alike. Biodiversity is essential for maintaining the health and stability of ecosystems, which provide crucial services such as pollination, water purification, and carbon sequestration. The extinction of species disrupts these services, making ecosystems less resilient to environmental changes and threatening the resources that humans depend on. The decline of insect populations, in particular, has raised alarms in recent years. Insects play a fundamental role in ecosystems, from pollinating plants to breaking down organic matter and serving as food for other species. The loss of pollinators, such as bees and butterflies, is already affecting agriculture, as many of the crops that humans rely on for food depend on pollination. The decline of insects also has cascading effects on the food web, as animals that rely on insects for food, such as birds and amphibians, are also threatened. The causes of insect decline are varied, but habitat loss, pesticide use, and climate change are major contributors. Despite the enormity of these challenges, there are reasons for hope. Around the world, individuals, communities, governments, and organizations are taking action to address the environmental crisis and build a more sustainable future. The rise of renewable energy technologies, such as solar and wind power, is providing an alternative to fossil fuels and helping to reduce carbon emissions. In many countries, renewable energy is now more affordable than traditional fossil fuels, and investment in clean energy is growing rapidly. Advances in energy storage, grid infrastructure, and electric transportation are also paving the way for a transition to a low-carbon economy. In addition to technological solutions, there is a growing recognition of the need to protect and restore ecosystems. Reforestation and afforestation efforts, planting trees to restore degraded forests and create new forests, are helping to sequester carbon, restore biodiversity, and improve soil and water quality. The protection of marine ecosystems through the establishment of marine protected areas, MPAs, is also playing a critical role in conserving biodiversity and promoting the recovery of fish populations. In many cases, MPAs have led to the resurgence of marine species, improving the health of entire ecosystems and benefiting local communities. One of the most promising developments in recent years is the increasing momentum of global climate action. The Paris Agreement, adopted in 2015, represents a landmark commitment by nearly every country in the world to limit global warming to well below 2 degrees Celsius (3.6 degrees Fahrenheit) above pre-industrial levels, with efforts to limit the temperature increase to 1.5 degrees Celsius (2.7 degrees Fahrenheit). While the agreement is a critical step toward addressing climate change, meeting these targets will require significant reductions in greenhouse gas emissions, as well as adaptation measures to help communities cope with the impacts of climate change. At the same time, youth-led movements and grassroots organizations are pushing for more ambitious climate action and environmental justice. Young activists such as Greta Thunberg and Vanessa Nakate have become powerful voices in the global climate movement, calling for immediate and bold action to address the climate crisis. These movements have galvanized millions of people around the world to demand accountability from governments and corporations and to advocate for policies that prioritize sustainability, equity, and justice. Environmental justice is an increasingly important aspect of the global conversation about climate change and environmental protection. Historically, the impacts of environmental degradation have disproportionately affected marginalized communities, often low-income, indigenous, or people of color, who are least responsible for the environmental harm but bear the greatest burden. Environmental justice seeks to address these inequities by ensuring that all people have access to clean air, water, and land, and that the benefits and burdens of environmental policies are distributed fairly. This movement highlights the need for inclusive, community-driven solutions to environmental challenges, particularly in the face of climate change. As humanity confronts the challenges of the Anthropocene, we are also beginning to recognize the importance of reconnecting with nature. For much of the modern era, humans have viewed themselves as separate from and in control of the natural world. However, the environmental crisis is forcing a rethinking of this relationship, as we come to understand that human well-being is deeply intertwined with the health of ecosystems. There is a growing movement to incorporate traditional ecological knowledge, held by indigenous communities who have lived in harmony with nature for millennia, into modern conservation and sustainability practices. This knowledge offers valuable insights into how to manage natural resources sustainably and how to restore degraded ecosystems. Rewilding is one example of how this shift in perspective is being put into practice. Rewilding involves allowing ecosystems to return to their natural state by removing human interference and reintroducing species that have been lost from the environment. By restoring natural processes, such as predator-prey dynamics and fire regimes, rewilding can help ecosystems recover and become more resilient to environmental changes. In some cases, rewilding has led to remarkable recoveries of species and habitats, demonstrating the potential for nature to heal itself when given the opportunity. As we navigate the complex and interconnected challenges of the 21st century, it is clear that the future of planet Earth depends on the choices we make today. The environmental crisis is not just a scientific or technological issue. It is a moral and ethical challenge that calls on humanity to reflect on our relationship with the planet and with each other. By embracing sustainability, protecting biodiversity, and addressing climate change, we can create a future where both humans and nature thrive. The story of planet Earth is one of resilience, adaptation, and change. For billions of years, Earth has evolved through cycles of creation and destruction, with life finding a way to survive and flourish in the face of unimaginable challenges. As we confront the environmental challenges of the modern era, we are reminded that while Earth is resilient, it is also vulnerable. The choices we make will determine whether the planet remains a place of beauty, diversity, and life for future generations. In the end, the secrets of planet Earth are not just about the forces that have shaped the planet over eons. They are about the choices we make as stewards of this unique and extraordinary world. Our future is deeply tied to the fate of the planet, and by working together to protect and restore the Earth, we can ensure that its wonders continue to inspire, sustain, and nurture life for millennia to come. The journey of discovery continues, and with it, the hope that humanity can rise to the challenge of living in harmony with the planet that has given us everything. As we continue our journey through the unfolding story of planet Earth, we now approach the delicate balance between hope and uncertainty that defines our relationship with the future. In the face of accelerating environmental crises, climate change, biodiversity loss, pollution, and resource depletion, there remains an enduring optimism in humanity's capacity to innovate, adapt, and make choices that can lead to a more sustainable world. The question that lies ahead is whether we can act quickly and decisively enough to prevent irreversible damage to the systems that sustain life. What is clear is that the future of the planet and the future of humanity are intimately intertwined, and the actions we take now will reverberate for generations. One of the most promising areas of innovation is in the development of clean, renewable energy technologies. The shift away from fossil fuels, whose extraction and combustion have driven climate change, air pollution, and environmental degradation, is essential for mitigating global warming and creating a sustainable energy future. Over the past 2 decades, significant advances in solar, wind, and geothermal energy have made these sources of power more affordable and accessible than ever before. In some parts of the world, renewable energy is now cheaper than coal or natural gas, and investments in these technologies are growing rapidly. Solar energy, in particular, has become a beacon of hope for a low-carbon future. Advances in photovoltaic technology have made solar panels more efficient and less expensive, allowing households, businesses, and entire countries to harness the power of the sun. Solar farms are being built on a large scale, and in many regions, solar power is now the fastest-growing source of electricity. Innovations such as solar roofs and solar-integrated building materials are bringing clean energy to urban environments, and off-grid solar systems are providing power to remote areas that previously lacked access to electricity. The potential of solar energy is vast, and as the technology continues to improve, it could play a central role in decarbonizing the global economy. Wind energy is another vital component of the transition to a renewable energy future. Offshore wind farms, which harness the powerful winds that blow across the oceans, are emerging as a key solution for meeting the energy demands of coastal regions. The development of larger, more efficient wind turbines has allowed wind energy to become one of the most competitive sources of electricity in the world. Moreover, advances in battery storage technology are enabling renewable energy systems to store power and provide a reliable supply even when the wind isn't blowing or the sun isn't shining. These innovations are addressing one of the main challenges of renewable energy, intermittency, and are helping to make clean energy a viable alternative to fossil fuels. In addition to the energy transition, there is growing momentum around the concept of the circular economy, a system that moves away from the traditional linear model of take, make, dispose, and instead focuses on reducing waste, reusing materials, and recycling resources. The circular economy seeks to minimize the environmental impact of production and consumption by keeping materials in use for as long as possible, reducing the need for new resource extraction, and preventing waste from accumulating in landfills or the natural environment. This approach is particularly relevant in addressing the global plastic pollution crisis, as it encourages the design of products that can be easily repaired, recycled, or biodegrade. The rise of electric vehicles, EVs, is another key aspect of the shift towards sustainability. Transportation is one of the largest sources of greenhouse gas emissions, and the widespread adoption of electric cars, buses, and trucks could significantly reduce emissions from this sector. Governments around the world are introducing policies to encourage the transition to electric mobility, including subsidies for EV purchases, investments in charging infrastructure, and commitments to phase out the sale of gasoline and diesel vehicles in the coming decades. Meanwhile, advances in battery technology are extending the range of electric vehicles and making them more affordable for consumers. Beyond technological solutions, a growing awareness of the importance of ecosystems and natural processes is driving efforts to protect and restore the environment. Rewilding projects, which aim to restore ecosystems by reintroducing native species and allowing natural processes to take over, are gaining traction in various parts of the world. In Europe, for example, efforts are underway to reintroduce large herbivores, such as bison and wild horses, to landscapes where they have been absent for centuries. These animals play a crucial role in shaping ecosystems by grazing on vegetation, dispersing seeds, and creating habitats for other species. Rewilding not only helps restore biodiversity, but also enhances the resilience of ecosystems to climate change and other environmental stressors. Nature-based solutions are increasingly recognized as powerful tools for addressing both climate change and biodiversity loss. The protection and restoration of forests, wetlands, mangroves, and peatlands can sequester carbon, reduce the risk of floods and droughts, and provide habitat for wildlife. These ecosystems are often referred to as carbon sinks because they absorb more carbon dioxide than they release, helping to offset emissions from human activities. In addition to their climate benefits, these ecosystems provide a wide range of ecosystem services, including water purification, soil stabilization, and the regulation of local climates. The concept of ecosystem services, where natural systems provide essential benefits to human societies, is becoming central to discussions about sustainability. The realization that healthy ecosystems underpin economies, livelihoods, and human well-being is driving new approaches to conservation and land management. Policies that value and protect ecosystem services, such as payment for ecosystem services (PES) schemes, are being implemented in various regions to incentivize landowners and communities to preserve forests, wetlands, and other critical habitats. These policies recognize that investing in nature is not just about environmental protection. It is also about ensuring the long-term viability of human societies. However, technological and ecological solutions alone will not be enough to address the challenges of the Anthropocene. A fundamental shift in how we live, consume, and think about our relationship with the planet is required. This shift is already beginning to take shape as more people embrace sustainable lifestyles, reduce their environmental footprint, and advocate for systemic change. Movements such as zero waste, slow living, and minimalism are encouraging individuals to rethink their consumption habits, prioritize quality over quantity, and seek fulfillment in experiences rather than material possessions. These movements reflect a growing recognition that the current trajectory of endless growth and consumption is not sustainable, and that a more balanced, mindful approach to living is needed. Education and awareness play a crucial role in driving this shift. Environmental education programs in schools, universities, and communities are helping to raise awareness about the interconnectedness of natural systems and the importance of sustainability. As younger generations grow up with a deeper understanding of the environmental challenges facing the planet, they are becoming powerful advocates for change. Youth-led movements, such as the climate strikes and Fridays for Future, are demanding that governments and businesses take urgent action to protect the planet for future generations. These movements are not only raising awareness, but also holding decision-makers accountable and pushing for ambitious policies to address the climate and biodiversity crises. At the international level, there is a growing recognition that global cooperation is essential for addressing the environmental challenges of the 21st century. Climate change, biodiversity loss, and pollution are transboundary issues that cannot be solved by any one country acting alone. International agreements, such as the Paris Agreement on Climate Change and the Convention on Biological Diversity, provide frameworks for collective action, but they require political will and commitment to be effective. As the impacts of environmental degradation become more apparent, there is hope that nations will come together to strengthen these agreements and take bold steps toward a sustainable future. As we look to the future, one of the most profound questions facing humanity is how we can balance technological progress and economic development with the need to protect the planet's natural systems. In many ways, this is the central challenge of the Anthropocene: how to ensure that human activities do not undermine the very foundations of life on Earth. The choices we make in the coming decades will determine whether we can transition to a sustainable and resilient future, or whether we will push the planet's systems beyond their tipping points. Earth's climate, ecosystems, and resources are finite, and their resilience has limits. Scientists have identified several planetary boundaries, thresholds that, if crossed, could lead to irreversible environmental change. These include boundaries for climate change, biodiversity loss, deforestation, freshwater use, and chemical pollution. Staying within these boundaries is essential for maintaining the stability of Earth's systems and ensuring a safe operating space for humanity. Exceeding these limits could lead to cascading effects that destabilize ecosystems, disrupt economies, and threaten human health and well-being. However, the concept of planetary boundaries also offers a framework for hope. By recognizing the limits of Earth systems and taking action to stay within them, we can create a future where human societies and natural ecosystems thrive together. This vision of a sustainable future is not about returning to a pre-industrial way of life, but about reimagining how we live, produce, and consume in ways that are in harmony with the planet. It is about using our ingenuity and creativity to solve the challenges of the 21st century while respecting the natural limits of the Earth. In the end, the story of planet Earth is a story of resilience, adaptation, and renewal. The planet has survived asteroid impacts, volcanic eruptions, ice ages, and mass extinctions. Life has persisted and evolved through countless challenges, finding new ways to thrive in the face of adversity. As we confront the challenges of the Anthropocene, we are reminded that the Earth is a dynamic, living system that has the capacity to recover and regenerate, if given the opportunity. The secrets of planet Earth continue to unfold, revealing not just the complexity of its systems, but also the fragility of its balance. Our relationship with the planet is at a crossroads, and the choices we make today will shape the world for generations to come. By embracing sustainability, protecting ecosystems, and rethinking our place in the natural world, we can create a future where both humanity and the Earth thrive in harmony. The path forward is challenging, but it is also filled with opportunity, and the story of planet Earth is far from over. As we delve even further into the unfolding narrative of planet Earth, we now turn to the profound question of how humanity's relationship with the planet might evolve in the coming decades. With mounting environmental challenges and technological advancements reshaping the landscape of human potential, we stand on the brink of either transformative progress or irreversible damage to Earth's natural systems. This critical moment, defined by the choices we make, presents an opportunity to create a future where human society and nature coexist in balance. If we embrace both innovation and a deep respect for the ecological limits of our world. One of the most significant factors shaping our future will be how we manage the intersection of technology and sustainability. Technological advancements, particularly in fields like artificial intelligence, biotechnology, and renewable energy, are offering unprecedented tools to address the environmental crises we face. However, the key to realizing their full potential will lie in ensuring that these innovations are deployed in ways that enhance, rather than undermine, the health of the planet. Artificial intelligence, AI, for example, is poised to revolutionize how we understand and manage Earth's complex systems. AI can analyze vast amounts of environmental data, identify patterns, and predict future trends in ways that were previously unimaginable. This capability is already being harnessed to improve everything from climate modeling and biodiversity monitoring to sustainable agriculture and conservation efforts. AI-powered climate models allow scientists to simulate different future scenarios, providing insights into how climate change might unfold under various policy decisions. This level of precision and foresight can guide governments, industries, and communities toward more informed, sustainable choices. In agriculture, AI is helping farmers optimize crop yields while minimizing the environmental impact of farming. Precision agriculture, enabled by AI and satellite technology, allows farmers to monitor soil health, water usage, and crop growth in real time, reducing the need for excessive fertilizers, pesticides, and water. This not only enhances food production, but also reduces the ecological footprint of agriculture, a critical step in addressing food security and environmental sustainability in an era of climate change. Another promising area of innovation lies in biotechnology, which is offering new solutions for both mitigating climate change and restoring damaged ecosystems. Advances in genetic engineering and synthetic biology are being used to develop crops that are more resilient to extreme weather conditions, such as drought or flooding. These crops require fewer resources, such as water and fertilizers, and can help ensure food security in the face of a changing climate. At the same time, scientists are exploring the potential of engineered microorganisms and enzymes to break down plastic waste, remove carbon dioxide from the atmosphere, and even regenerate degraded ecosystems. One of the most exciting frontiers of biotechnology is the development of carbon capture and storage, CCS, technologies, which aim to remove carbon dioxide from the atmosphere and store it in ways that prevent it from contributing to global warming. Direct air capture, DAC, systems, which use chemical processes to extract CO2 from the air, are being developed and deployed on a small scale, but they hold the potential to play a significant role in mitigating climate change. In addition, natural carbon sinks, such as forests, wetlands, and oceans, are being restored and protected through a combination of technology and conservation practices, helping to sequester carbon and reduce the overall concentration of greenhouse gases in the atmosphere. However, the deployment of these technologies comes with ethical and environmental considerations. Geoengineering, for example, the deliberate large-scale manipulation of Earth's climate, has been proposed as a potential way to combat global warming. Techniques such as solar radiation management, SRM, which aims to reflect a portion of the sun's energy back into space, could theoretically cool the planet. However, these interventions carry significant risks, including unintended consequences for weather patterns, biodiversity, and the global water cycle. The debate over geoengineering highlights the need for caution, governance, and careful consideration of the long-term impacts of technological interventions on natural systems. The future of energy will also play a decisive role in shaping humanity's relationship with the Earth. The transition from fossil fuels to renewable energy sources is already underway, but its success will depend on scaling up these technologies and integrating them into every aspect of the global economy. Solar, wind, and geothermal energy are leading the way, but other innovative technologies such as hydrogen fuel cells, advanced nuclear reactors, and wave energy are also showing promise. The development of a smart, interconnected energy grid that can efficiently distribute renewable energy across regions is essential for ensuring that clean energy can meet the demands of modern society. Battery storage technology is another key component of this transition. The ability to store energy generated from renewable sources and release it when needed is critical for addressing the intermittency of solar and wind power. Recent breakthroughs in battery technology, including the development of longer-lasting, more efficient batteries, are helping to solve this challenge. Advances in electric vehicles, EVs, powered by these improved batteries, are rapidly transforming the transportation sector, offering a cleaner alternative to gasoline and diesel-powered vehicles. As renewable energy technologies become more widespread, we are also seeing the rise of decentralized energy systems. In many parts of the world, individuals and communities are installing solar panels, wind turbines, and other renewable energy systems to generate their own electricity, reducing their reliance on centralized power grids. This shift toward energy independence not only helps reduce greenhouse gas emissions, but also empowers communities to take control of their energy production and consumption. Decentralized energy systems also increase resilience, as communities are less vulnerable to power outages and fluctuations in energy prices. While these technological advancements offer hope, they must be accompanied by profound changes in how we think about and interact with the natural world. A key part of this shift involves redefining the concept of progress. For much of human history, progress has been equated with economic growth, industrial expansion, and the extraction of natural resources. However, this model of progress is unsustainable in the long term, as it places increasing pressure on the planet's finite resources and disrupts the delicate balance of its ecosystems. A new model of progress is emerging, one that prioritizes sustainability, well-being, and ecological balance over unbridled economic growth. This model, often referred to as sustainable development, seeks to meet the needs of the present without compromising the ability of future generations to meet their own needs. It emphasizes the importance of balancing environmental protection, social equity, and economic prosperity. By adopting this approach, we can work toward a future where human societies thrive within the limits of Earth's natural systems. In this context, the concept of regenerative approaches to agriculture, business, and development is gaining traction. Regenerative practices go beyond sustainability. They aim to restore and enhance natural systems, making them more resilient and productive. Regenerative agriculture, for example, focuses on building healthy soil, increasing biodiversity, and improving water management, all while sequestering carbon and improving crop yields. By working in harmony with nature, rather than against it, regenerative practices offer a path forward that not only sustains human life, but also restores the planet's ecosystems. Education and cultural change are also essential components of this shift. Environmental education programs, sustainable development curricula, and initiatives that foster a deeper connection with nature are helping to cultivate a new generation of leaders who understand the importance of sustainability. The growing popularity of movements that promote mindfulness, slow living, and ecological awareness reflects a broader cultural shift toward valuing quality of life, community, and the health of the planet over material consumption. At the same time, global governance will be crucial in addressing the planetary challenges of the future. International cooperation on climate change, biodiversity conservation, and environmental protection is more important than ever. The Paris Agreement on Climate Change and the United Nations Sustainable Development Goals, SDGs, provide frameworks for global action, but achieving these goals will require the political will, commitment, and collaboration of nations, businesses, and civil society. In navigating the future of planet Earth, equity and justice must be at the heart of our efforts. Climate change and environmental degradation disproportionately affect vulnerable populations, particularly those in developing countries and marginalized communities. Environmental justice demands that we recognize and address these inequities, ensuring that all people have access to clean air, water, food, and a healthy environment. It also requires that we give voice to those most affected by environmental harm and ensure that the benefits of sustainability are shared equitably. As we contemplate the future, we must also recognize that Earth is not merely a resource to be managed. It is a living, interconnected system that sustains life in all its forms. The health of the planet is directly linked to the health of human societies, and our well-being is dependent on the well-being of the ecosystems we inhabit. This understanding is leading to a new way of thinking about our place on Earth, one that views humans as part of the natural world rather than separate from it. In this emerging vision of the future, humanity has the potential to become stewards of the planet, working in partnership with nature to create a world that is both prosperous and sustainable. The challenges we face are immense, but they are not insurmountable. The choices we make in the coming years will determine the course of life on Earth for centuries to come. By embracing innovation, equity, and a deep respect for the planet's natural systems, we can create a future where both people and the planet thrive. As the story of planet Earth continues to unfold, we are reminded that the planet has endured for billions of years, adapting and evolving through countless changes. Life on Earth is resilient, but it is also fragile. The future of the planet rests in our hands, and with it, the future of life itself. Through collective action, responsible stewardship, and a renewed connection to the natural world, we can ensure that the Earth remains a vibrant, living planet for generations to come. The next chapter in Earth's history is being written now, and it is up to us to shape it. As we move deeper into the story of planet Earth, we now stand at a moment where humanity's capacity to envision and create a more harmonious future with the planet will be tested like never before. We are not only facing urgent environmental challenges, but we are also redefining the fundamental relationship between human society and the natural world. This new chapter brings together science, technology, culture, and ethics, weaving them into a cohesive narrative that seeks to balance human progress with the ecological limits of the Earth. The choices we make will shape not only the future of humanity, but the entire web of life on this planet. One of the defining features of the coming decades will be our ability to adapt to and mitigate the effects of climate change. Already, global temperatures have surpassed critical thresholds, and the consequences of this warming are becoming more apparent with each passing year. However, this period of rapid environmental change also offers an opportunity to rethink how we live, work, and interact with the natural world. Adaptation, resilience, and innovation will be essential as we learn to cope with rising sea levels, more frequent and intense storms, and the shifting availability of resources like water and food. Adaptation strategies are being developed and implemented at various levels, from local communities to global policy initiatives. In coastal regions, for example, cities are investing in infrastructure projects to protect against rising seas and storm surges. Seawalls, flood barriers, and stormwater management systems are being built to safeguard homes, businesses, and essential services. In some areas, natural solutions such as restoring wetlands and mangroves are being prioritized, as these ecosystems provide natural buffers against storms and rising waters while also supporting biodiversity and sequestering carbon. Urban areas are at the forefront of many adaptation efforts, as cities are particularly vulnerable to the impacts of climate change. Green infrastructure such as green roofs, permeable pavements, and urban forests is being used to mitigate the urban heat island effect and improve stormwater management. These solutions not only enhance the resilience of cities to climate change, but also improve the quality of life for urban residents by providing more green spaces, reducing pollution, and promoting biodiversity within cities. Additionally, the concept of smart cities, which leverage technology and data to optimize energy use, transportation, and resource management, is gaining traction as a way to make urban environments more sustainable and adaptive. In agriculture, adaptation is equally critical, as climate change alters precipitation patterns, increases the frequency of droughts, and intensifies extreme weather events. Farmers around the world are being forced to adapt to new realities. Climate-smart agriculture, CSA, is an approach that integrates sustainable agricultural practices with resilience-building strategies. By adopting techniques such as crop diversification, water-efficient irrigation systems, and soil conservation methods, farmers can reduce their vulnerability to climate change while maintaining productivity. Moreover, the development of climate-resilient crops, plants that are genetically engineered or selectively bred to withstand heat, drought, or salinity, is helping to ensure food security in the face of a changing climate. At the same time, efforts to mitigate climate change are accelerating, driven by the urgency of reducing greenhouse gas emissions and transitioning to a low-carbon economy. While the shift to renewable energy sources such as solar, wind, and hydropower is well underway, decarbonizing other sectors such as transportation, industry, and agriculture remains a significant challenge. However, advances in technology are opening up new possibilities for reducing emissions across all sectors. In the transportation sector, electric vehicles, EVs, are rapidly becoming mainstream, with many countries setting targets to phase out the sale of gasoline and diesel vehicles over the coming decades. The electrification of public transportation systems, such as buses and trains, is also contributing to the reduction of emissions from the transportation sector. Innovations in battery technology, such as solid-state batteries and lithium-sulfur batteries, are extending the range and efficiency of EVs, making them more accessible and affordable to consumers. Additionally, the development of green hydrogen, hydrogen produced using renewable energy, offers the potential to decarbonize industries that are difficult to electrify, such as heavy transportation, aviation, and steel production. In industry, new approaches to manufacturing and production are being explored to reduce emissions and minimize waste. The concept of the circular economy, which focuses on designing products for reuse, repair, and recycling, is gaining momentum as businesses and governments seek to reduce their environmental footprint. By shifting away from the traditional linear model of take, make, dispose, the circular economy emphasizes keeping materials in use for as long as possible, thereby reducing the need for new resource extraction and minimizing waste. Technological advancements in carbon capture, utilization, and storage (CCUS) are also playing a critical role in mitigating climate change. CCUS technologies capture carbon dioxide emissions from industrial processes or directly from the atmosphere and either store them underground or use them in products such as concrete, plastics, or fuels. While these technologies are still in the early stages of deployment, they have the potential to significantly reduce global emissions, particularly in industries where decarbonization is difficult. However, technology alone will not solve the climate crisis. There is a growing recognition that addressing climate change requires systemic change at every level of society. Governments, businesses, and individuals all have a role to play in transitioning to a sustainable and low-carbon future. This transition will require bold policy actions, such as carbon pricing, subsidies for renewable energy, and the phasing out of fossil fuel subsidies. At the same time, businesses will need to adopt more sustainable practices, reduce their carbon footprints, and invest in clean technologies. For individuals, the choices we make, how we travel, what we eat, how we consume, will also be critical in shaping the future of the planet. In addition to mitigating and adapting to climate change, protecting and restoring biodiversity will be essential for ensuring the health of the planet's ecosystems and the resilience of human societies. Biodiversity provides critical ecosystem services, from pollination and pest control to water purification and carbon sequestration. However, human activities are driving unprecedented rates of species extinction, and the loss of biodiversity threatens the stability of ecosystems and the benefits they provide. Conservation efforts are focusing not only on protecting individual species, but also on preserving entire ecosystems. Large-scale initiatives, such as the establishment of protected areas and wildlife corridors, are helping to conserve habitats and allow species to migrate and adapt to changing environmental conditions. In addition, restoration projects are underway to rehabilitate degraded ecosystems, such as reforesting cleared lands, restoring wetlands, and reviving coral reefs. These efforts are critical for reversing biodiversity loss and enhancing the resilience of ecosystems to climate change. A key element of protecting biodiversity is recognizing the rights and knowledge of indigenous communities. Indigenous peoples have long been stewards of the land, and their traditional knowledge offers valuable insights into how to manage ecosystems sustainably. Across the world, indigenous communities are leading efforts to protect forests, rivers, and other natural areas from deforestation, mining, and other forms of exploitation. Collaborative conservation efforts that involve indigenous communities and respect their rights and sovereignty are essential for achieving long-term conservation goals and ensuring that environmental justice is upheld. The future of planet Earth will also be shaped by how we manage and share resources. As the global population grows and the demand for food, water, and energy increases, ensuring the equitable distribution of resources will be one of the greatest challenges of the 21st century. Water scarcity, in particular, is emerging as a critical issue in many parts of the world, exacerbated by climate change and unsustainable water use. Ensuring access to clean water and sanitation for all, while managing water resources sustainably, will require innovative solutions, from improving water efficiency in agriculture and industry to developing new technologies for water purification and desalination. The question of equity extends beyond resource distribution to the impacts of climate change and environmental degradation. Climate change disproportionately affects vulnerable communities, particularly in developing countries that are least responsible for global emissions. Addressing this inequity will require a commitment to climate justice, which ensures that the costs and benefits of climate action are distributed fairly and that those most affected by environmental harm have a voice in decision-making processes. This includes providing financial and technical support to developing countries to help them adapt to climate change and transition to clean energy. As we contemplate the future of the planet, it is also worth considering the long-term trajectory of human civilization. Advances in space exploration and technology are opening up new possibilities for humanity's relationship with the cosmos. Missions to Mars, the establishment of lunar bases, and the search for life beyond Earth are not just technological milestones. They raise profound questions about humanity's role in the universe and our responsibilities as stewards of Earth. The idea of becoming a multiplanetary species captures the imagination, but it also reminds us that Earth is our only home for the foreseeable future, and its health must remain our top priority. In the coming decades, the exploration of space and the search for life on other planets may provide us with new perspectives on our place in the universe. The discovery of even microbial life elsewhere would have profound implications for our understanding of life's potential and the uniqueness of Earth's biosphere. It would also reinforce the importance of preserving the conditions that make life possible on our planet. As we look to the future, one of the most powerful tools at our disposal is hope. Hope is not a passive emotion, but a force that drives action, innovation, and resilience. The environmental challenges we face are daunting, but humanity has the capacity to rise to the occasion, to harness the best of science, technology, and collective will to create a future that is both sustainable and just. The road ahead will require difficult choices, but it is also filled with opportunities to redefine our relationship with the planet and each other. The story of planet Earth is one of constant change, adaptation, and renewal. It is a story that has been shaped by forces both within and beyond our control, and now, more than ever, it is a story that we have the power to influence. The next chapter is still being written, and its outcome will depend on the choices we make today. We have the knowledge, the tools, and the ability to create a future where both humanity and the Earth thrive. The question is, will we act in time? The future of planet Earth rests in our hands, and the path we choose will determine the fate of life on this extraordinary and irreplaceable world. The journey continues, and with it, the hope that we can rise to the challenge of living in harmony with the planet that sustains us. As we continue our exploration of planet Earth's future, we now arrive at the heart of an essential and deeply philosophical question. What kind of world do we want to create for future generations? This question encompasses more than technological solutions, environmental policies, or economic systems. It speaks to the very core of what it means to live sustainably and harmoniously with the planet. As we stand on the threshold of a new era, the vision of a better world will not be driven solely by technological innovation, but by a profound shift in our values, ethics, and relationship with nature. The future of planet Earth will be shaped by the collective choices of humanity. To ensure that this future is one where both people and ecosystems thrive, we must embrace the concept of planetary stewardship, a recognition that we are caretakers of a planet that is part of a broader, interconnected system of life. Planetary stewardship goes beyond simply addressing the environmental crises of today. It involves rethinking how we interact with the planet, how we measure progress, and how we define well-being. One of the most critical aspects of planetary stewardship is the idea of living within the limits of Earth's natural systems. The concept of ecological boundaries has become central to discussions of sustainability, recognizing that Earth's resources, its water, air, soil, and biodiversity, are finite and must be used wisely. The Planetary Boundaries Framework, developed by scientists, outlines 9 key environmental thresholds that must not be crossed if we are to maintain a stable and hospitable planet. These include limits on climate change, biodiversity loss, land use, freshwater consumption, and chemical pollution. By staying within these boundaries, we can ensure that Earth systems continue to function in ways that support life. This shift in thinking also requires a redefinition of progress. For much of modern history, progress has been measured in terms of economic growth, technological advancement, and material accumulation. However, as the environmental impacts of unchecked growth have become more apparent, there is a growing recognition that true progress must be measured not only in economic terms, but also in terms of human and ecological well-being. This new vision of progress places value on sustainability, equity, community, and quality of life. It prioritizes long-term resilience over short-term gains, and it recognizes that the health of the planet is inseparable from the health of human societies. The idea of the well-being economy is gaining traction as an alternative to the traditional model of growth. A well-being economy places people and the planet at the center of economic decision-making. It emphasizes policies and practices that promote social and environmental health, rather than focusing solely on increasing GDP. In a well-being economy, success is measured by indicators such as access to clean air and water, mental and physical health, equitable distribution of resources, and the protection of biodiversity. This approach reflects a more holistic understanding of what it means to thrive, not just as individuals, but as part of a broader community of life. One of the key principles of planetary stewardship is the need to preserve and restore ecosystems. Healthy ecosystems are the foundation of life on Earth, providing essential services such as pollination, water filtration, carbon sequestration, and soil fertility. Yet, human activities have placed unprecedented pressure on these systems, pushing many to the brink of collapse. The destruction of forests, wetlands, coral reefs, and other ecosystems not only threatens biodiversity, but also undermines the ability of these systems to regulate the climate and support human life. The restoration of ecosystems, often referred to as rewilding or ecosystem restoration, is a critical part of the effort to repair the damage done by human activity. Rewilding projects are taking place around the world, aiming to restore natural processes and bring back species that have been lost. For example, efforts to reintroduce large predators, such as wolves and lynx, to landscapes where they have been hunted to extinction are helping to restore balance to ecosystems by controlling herbivore populations and allowing vegetation to recover. Similarly, reforestation and afforestation projects are working to rebuild forests that have been cleared for agriculture or development, enhancing biodiversity, sequestering carbon, and improving water cycles. Ocean restoration is also a growing focus of planetary stewardship efforts. Oceans play a vital role in regulating the Earth's climate, absorbing carbon dioxide, and providing habitat for countless species. Yet, overfishing, pollution, and warming waters are putting marine ecosystems at risk. Coral reef restoration, for instance, involves cultivating coral nurseries and transplanting healthy corals to degraded reefs, helping to revive these ecosystems. Protecting marine ecosystems through the creation of marine protected areas, MPAs, is also crucial for preserving biodiversity and promoting the recovery of fish populations. Beyond restoration, a broader shift is underway in how we think about our relationship with nature. Increasingly, there is recognition that nature should not be seen merely as a resource to be exploited, but as a partner in our collective future. Indigenous communities who have long practiced sustainable stewardship of the land offer valuable insights into how to live in harmony with the natural world. Their knowledge, which has been passed down through generations, emphasizes the interconnectedness of all living things and the importance of respecting the land, water, and air that sustain us. The rise of movements that emphasize ecological consciousness, such as Earth-centered law or the rights of nature movement, is a reflection of this shift in values. These movements advocate for recognizing ecosystems, species, and even natural features like rivers and mountains as having inherent rights, much like human rights. In some countries, this concept has already been enshrined in law. For example, in Ecuador, the Constitution recognizes the rights of nature, giving ecosystems legal standing to be protected from exploitation and harm. Similarly, New Zealand has granted legal personhood to the Whanganui River, acknowledging its cultural and spiritual significance to the Maori people. The rights of nature movement represents a fundamental change in how we view the environment. It challenges the idea that humans have dominion over the earth and instead promotes the idea of coexistence and mutual respect between humans and the natural world. This philosophy is not only rooted in indigenous traditions, but also in a growing body of ecological science that shows how deeply interconnected and interdependent all forms of life are. By recognizing the rights of nature, we are acknowledging that the health of ecosystems is inseparable from the health of human communities. At the same time, humanity's future on Earth will also be shaped by how we manage resources and ensure that they are used equitably. The concept of resource justice is becoming increasingly important in discussions about sustainability. Resource justice is based on the idea that the benefits of Earth's natural resources should be shared fairly and that the exploitation of these resources should not harm the environment or marginalize vulnerable communities. In practice, this means addressing issues such as land rights, access to water, and the fair distribution of energy resources. In the context of climate change, resource justice is closely linked to climate justice. Many of the communities most affected by climate change, such as indigenous peoples, small island nations, and low-income populations, have contributed the least to the problem. Ensuring that these communities have access to the resources they need to adapt to climate change, while also addressing historical injustices, is critical for building a more equitable and resilient world. This includes providing financial and technical support to help developing countries transition to clean energy, protect their ecosystems, and build climate-resilient infrastructure. Education and public engagement will also play a crucial role in shaping the future of planet Earth. As more people become aware of the environmental challenges we face, there is a growing movement toward taking individual and collective action. Grassroots organizations, environmental campaigns, and youth-led movements are bringing attention to issues such as climate change, deforestation, and plastic pollution, and they are driving change from the bottom up. These movements are not only raising awareness, but also inspiring governments and businesses to adopt more sustainable practices. At the heart of these efforts is the belief that every individual has the power to make a difference. Whether through reducing personal consumption, supporting sustainable businesses, advocating for policy changes, or participating in conservation efforts, individuals can contribute to the collective goal of protecting and restoring the planet. The rise of citizen science, where ordinary people collect data on biodiversity, climate, and pollution, also demonstrates how individuals can play a direct role in environmental research and decision-making. Ultimately, the future of planet Earth will depend on how we navigate the relationship between human society and the natural world. The challenges we face are immense, but they are not insurmountable. By embracing a vision of planetary stewardship, one that values sustainability, equity, and ecological balance, we can create a world where both people and nature thrive. The future is unwritten, but it is filled with possibility. Through innovation, collective action, and a renewed sense of responsibility toward the Earth, we have the power to shape a future that honors the planet's beauty, complexity, and life-giving systems. The choices we make today will echo across generations, determining the fate of life on this remarkable planet. The journey of planet Earth continues, and with it, the hope that we can rise to the challenge of being true stewards of this extraordinary world. In doing so, we can ensure that future generations inherit a planet that is vibrant, diverse, and capable of sustaining life in all its forms. A planet where humanity and nature coexist in harmony, now and for centuries to come. If you liked the video, then consider clicking on the recommendation and watch our other videos. Be sure to subscribe, and see you on our next interstellar trip.